Thank you so much for joining after lunch. You had before lunch an introduction to the SpeedRunEthereum, an introduction to Ethereum, and I think you should have by now a general understanding of what Ethereum is and a beginning of understanding of how to code and develop applications on Ethereum. I think now we are going to enter the weeds of Ethereum and really start doing a workshop, which is the challenge number one, right?
Yes.
Number one, and I'll let Tam actually introduce the workshop. And Tam is a member of Bidle Giddle and also a creator of Punk Wallet, right? No, yeah.
I'm a maintainer.
All right, all right. So please welcome Tam for the workshop and hope you enjoy. Thank you.
Thank you, guys. Welcome back. So I'm going to go through this decentralized staking app challenge. It's part of the SpeedRunEthereum. As you were already told, SpeedRunEthereum is a really nice way to get started with building on Ethereum. So this is supposed to be a workshop. So if you would like to, you can just try to follow the steps with me and do the challenge. We'll see. So you can go to speedrunethereum.com, and this is the decentralized staking app challenge. So what's this challenge about? Basically, it's a group funding effort. So you can imagine that you have an idea and you would like to raise some money. You can create an app and let everyone in the world to chip in to send you some money. We will set a goal, like for today, we'll go for 1 Ether. And if we reach that goal, we will send that Ether to another smart contract. And if we don't reach the goal, we will make sure that everyone who staked some money or some ETH can actually get back the funds. If you would like to follow along, you will need Node, Yarn, and Git. And this description is really nice. I will just go through all the checkpoints and start from scratch by cloning the repository. Yeah. Actually, I already downloaded this like half an hour ago, so if it won't work, I can just switch. Yeah, I have some backup. But it should be there in like a minute. Yeah. Okay, so what we have, let me open the code. Oh, no. The code is not there. Oh yeah, sorry, I should follow the descriptions. So now I need to check out the branch. And now I should be able to see what's inside. There are 2 main packages. One is Hardhat. We already talked about Hardhat. Hardhat is a really nice tool to get started to build on Ethereum. It will create a local blockchain for us, and also it can manage our smart contracts and deployments. And we have an XJS folder, which is basically the front end. So in my terminal, I'm going to do the Yarn chain. Oh no, I need this Yarn install first. Sorry about that. So Yarn install just downloads all the dependencies. And the Yarn chain is going to start our local blockchain where we can test our smart contract. There you go. And in another terminal, I'm going to type yarn deploy, which deploys the smart contracts. These smart contracts are under hard hat contracts. We have an example contract. This is the contract we would like to send the ETH. And we have the staker contract. This is the smart contract we are going to build today in the next hour. Is it better? Thank you. It's fine. Yeah, it's fine. But maybe the next one. Thank you. Ooh. Is it better? All right. So what we need first is we would like to track the balances. So if someone actually sends some ETH to the contract, we would like to know that how many what's the balance. And a nice way of doing that is a solidity type called mapping. We would like to know who was actually the staker, so actually the address, and the uint that is going to be the balance. Also, I'm marking with this variable as public. This will the Solidity compiler will actually create a getter function, so we can have access to this variable. Let me just deploy this one line again. Whoa. Yeah, lots of mistakes. Whoa. I'm dead. In order to start our front end, we can hit yarn start. This will open at localhost 3000. If you look inside the Next.js folder, this is where our app lives. And it's really powerful because you can just start creating anything and it will instantly show up. So if I just type hello, hello is there. Also, so far I only wrote one line of code to have to track the balances. And there is a debug contracts tab, and you can see that this function shows up, and you can read individual balances. Obviously, as no one had staked so far, if I just grab this burner wallet address and try to read the value, it is going to be 0. So our next step would be to write a stake function, and anyone can call that function, send some ETH, and start the crowdfunding. So in order to create a function in Solidity, you need a function keyword, just the name of the function. Right now, we don't have any inputs. And this public is the visibility specifier. Public means that I can reuse this function in the same contract here, and also it can be called externally. Also, I mark the contract payable, which so otherwise I won't be able to send ETH to this function. We would need to know that who was actually the one who called this function, and there are some built-in functions we can use. One of those is message.sender. and the amount which was sent, you can access it by message.value. I really like the Solidity docs cheat sheet. So if you go to the Solidity docs, there is a cheat sheet. And you can look up all these available stuff that you can use. So you can hear that the message that sender is actually the address, the sender of the message who actually called the function. So we will use these. We want to store the balance. So we can do message.sender is equals message.value. Also, we want to make sure that if someone calls the stake function multiple times, we just increment their balance. So actually, it should be the previous balance plus the current value. Also, you can make it a little bit shorter. I think if you use some programming language, this might be very familiar to you. So these two lines of code are the same. I'm going to deploy it again just to check how everything is going. So at the debug contracts tab, I can see that I have a new write function, and also I can send some ETH. If I try to call it, I will have an error because currently the balance of my burner wallet is at 0, and I can just grab some funds from the faucet. So we are testing locally. It's really easy to get some ETH. Also, if I want to stake like 0.3 Ether, there are no floating numbers in Ethereum. So with this little button, I can just calculate the proper amount, which is multiplied by 10 times 18. So once I called send, two things happened. First of all, the staker contract's balance went up with 0.3 ETH. And also, the balance of my burner wallet just went down. You can see that it actually went down more than 0.3 ETH because we had to pay for the transaction. So this is the skeleton of our stake function. The challenge also asked us to create an event, which is a really nice way if you want to build an interactive app. You can create events at Solidity, and the dApps can listen to those events. In order to declare an event, you need the event keyword. I will call it stake. And I want to know who was the one who actually staked, and I want to know the amount. And after I incremented the balance, I can do emit stake and reuse the message.sender. And the message.value. I'm going to deploy again and check if this part is working or not. So I'm going to stake like 0.25 ETH. Oh, I need to convert it. And if I check the events tab, it will show up. Also, just for sanity check, if I just take another 0.2 ETH, I should be able to read the balance. And it's incrementing. So this was the first part. So far we have a stake function, but there is no way to get the ETH out of the contract. We can only just send some ETH, but we also want to forward this ETH if we reached our goal. Today our goal will be 1 Ether. I can just copy this line. So this is a constant. I called it threshold, and we would like to collect 1 Ether. So we're going for multiple users. If I just create an incognito window, I have a new burner wallet, so it's just like simulating that I had 1 user who already staked, and someone else is coming along and try to stake as well. The goal is to reach 1 Ether. Also, we will create a deadline. So there will be like a staking period. And also, once we reach the deadline, we're going to check if all the staking, all the balances add up to 1 ETH. And if so, then we'll transfer the ETH to another smart contract. And if we didn't reach the goal, then we can just let all the users withdraw their Ether. So we are going to create a deadline. This block timestamp is the actual timestamp when we are going to deploy this contract to the blockchain. And for testing, I'm just going to use 30 seconds, so we can just test if it's actually working or not. I'm going to create a new function called execute. I'm marking this function external for now. Previously, I used public, which meant that I could use it. I could reuse it in the same contract, and that can be called also externally. I'm not planning to use this execute function inside this contract, so I marked it external. But others can still call this function. What I would like to make sure that this function can only be used only after the deadline. And the keyword I can use is require. I'm going to create a condition. So this is how you make sure that this function, which can be called by anyone, can be executed only after we reach the deadline. And we can just specify an error message, like that line is not there yet, or something like that. What we want to know is what's the balance of our contract. I'm going to create a new int to store that. Call it contract balance. And I need the current contract's address. I can access that like this. So this is the current contract, and it's the address of the current contract, and I can just get the balance. What I'm missing. So what I want to do is to check, well, if the current contract balance actually reached our threshold, that 1 Ether. And if so, we will do something. And if we didn't reach the goal, we will do something else. If we reach the goal, we would like to transfer all the funds to this example contract. This example contract variable is declared here, and during the constructor, the address is set up properly. Let me check. So this contract has a complete function I would like to call. Also, I would like to send the ETH, and you can do that with curly braces and specify the value. Oh no, sorry, that's the wrong case. So if we reach the threshold, we're going to call this example contract, and we're going to send all the ETH. Otherwise, we would like to make sure that everyone who sent already some money can withdraw their funds. I'm going to create a flag for that, which is a Boolean called open for withdraw. I will set it to false. And if we call this execute function and the threshold is not reached, we'll let people withdraw using this flag. Let me check if I can actually made a good smart contract, or I had some typo. But so far so good. So again, if the threshold was not met, we'll create a function which will let people to withdraw their money. First of all, we need to know how much, what is the balance of the current user who called this function. Also, we want to make sure that this withdraw function can be only called once we set the open for withdraw flag to true. And I will use the require again. And the error message will be something like not open for withdraw. Sending ETH from a contract can be a little bit tricky. I will just type out how we can do it and explain a little bit later. So this line will transfer the user balance to the sender. What we want to make sure is that this function can be only called once. So before we start to send the balance, we would like to make sure that the same user cannot call it over and over again. So I'm going to set the balance to 0. Also, this call message will return two variables. One is an indicator, whether it was successful or not, and the other is some data. We don't really need that data, so I'm just skip that part. And I want to make sure that actually this call was successful. Oh. Every time I like to just hit yarn compile just to see if my code still compiles and I can deploy it. So far so good. Let me check the UI, what we have. So now we have an execute function as well, not only a read and the stake function. And if I try to execute, I will get an error message because we haven't reached the deadline. What would be nice if we could just actually know what's how many seconds we have, because right now we only have the deadline like this. So that's why I'm going to create a view function just to know how much time we still have. I mark this function as view, which will indicate that inside this function I cannot change any state. So if I would like to do state changes like this, because this function is marked as view, and I try to deploy or compile my smart contract, it should fail, telling me that this function was declared as view, so I just cannot modify the state. Also, this function will return the time left, which is going to be uint. What I would like to do is just return the deadline and minus the current timestamp. But I would like to make sure that it might be a negative number. So if we already reached that line, I just want to return 0, that there is no time left anymore. So I'm going to check if deadline is actually greater than Baghdad timestamp. So we still have some time. And if so, let's return how many seconds we still have. Otherwise, I'm just going to return 0. I think it's always a good thing to test. Sorry, it's not return, it returns a uint. To test what we have. Another way to deploy is with the -- reset flag that will just completely create new contracts, and you can start from scratch. Oh no, time left says 0. Oh, the return statement. Sorry about that. Thank you. Time is a little bit difficult on local tests. If I just try to execute right now, it will say that the deadline is not reached, but the time left still shows that 29 seconds. I just need to create a transaction. I can just grab some more funds and refresh, or I can also just do some staking, like I would like to stake 1 ETH. And it says that there is no time, so I should be able to call the execute function. So I stake 1 Ether. This is just for a test. So we actually reach the threshold. If I call execute, the transaction was successful, and the balance went to 0, and it should be at the external external contract. So we reached our threshold, and even there is a nice UI for this. We actually staked 1 ETH, and we have this success message. But there are lots of problems with this smart contract, and I'm going to work on those a little bit more. So one possible problem can be if we already called this execute function. Let me create another scenario. So let's say that we won't reach the threshold. I deployed it again, so this is a completely new smart contract, and I'm gonna stake only 0.2 Ether, and I will wait a little bit in order to reach the deadline. Almost there. So I can call the execute function. Oh, it says that line is not there. Maybe I just need to refresh. Oh no. All right, so I was able to call the execute function, but because the threshold was not reached, actually the money is still here. And one really big problem can be if someone comes along and tries to stake again, we still let them stake. On the other hand, there is just no way to get that ETH back again, because when he will try to withdraw the Ether, oh no, it was successful. I made a mistake. Why did that work? Oh, sorry. So actually, when I didn't reach the threshold, I set the open for withdrawal to true. My bad. Let me try it again. So let's imagine that actually there is enough Ether in the contract, and I will call execute. Still 6 seconds left. All right. So staking was successful. We transferred all the balance to the example smart contract, but we still let people stake. So if I just stake another Ether, and I try to withdraw, it says that actually the contract is not open for withdrawal. So what we want to do is make sure that once we call the execute function, we shouldn't really let people to stake, or at least shouldn't let people funds stuck in the contract. So I will just add new requirements, and one of the requirements is going to be that if we already called the complete function, then this completed flag will be true. So I want to make sure that the staking is not completed yet. This actually means that the staking was already successful and we reached the threshold. One more thing we can do is that actually the staking was not successful and we already opened for withdrawal. We can also just require that the contract is not open for withdrawal. So there will be no way to call this execute function multiple times. And actually, I would like to do kind of the same for the stake function. But as code duplication is not really a nice way, I will show you how you can create a so-called modifier to bundle these requirements into one single modifier. I'm going to call it not completed. Ooh. And instead of duplicating these lines of code, I'm just going to have it at one place. And this special syntax allows us to actually call the function. So I'm going to mark the stake function with this modifier and the execute function with this modifier. This will make sure that if we already finished the staking, then we shouldn't be able to stake, so funds won't get locked in the smart contract. Let me check if the code still compiles. Oh no. Yes, so I can't just grab this variable from another smart contract. I just need to access it. And actually, as this is a variable and was marked as a public, the Solidity compiler just created a getter function for it. So the proper syntax will be this, or at least should be this. I think now we're getting there. One more thing which should be nice is to create a receive function. So by default, smart contracts cannot receive any money. So if I try to send money to this staker contract right now, there is this little facet. Sorry, I'm just gonna copy the address, and I have this little facet. So what I'm trying to do is just send 1 Ether to this contract, but it fails with an error and says that there is no fallback or receive function, and I'm going to implement that one. Receive is a special function, so we don't need the receive. We don't need the function keyword at all. Receive function has to be marked as external and payable. And what we want to do is just pretend that if anyone sends some money to, or sends some ETH to the contract, then he's also a staker. So I can just reuse my my stake function from here. Let me deploy this again. I skip the parentheses. All right. Just one more test on localhost. And after that, I will try to deploy this. If everything goes well, I will try to deploy this to a testnet or some mainnet. So let's pretend that from this account, I'm going to stake like 0.5 ETH. Oh, I need to redeploy my contracts. So again, let's pretend that from this account, I stake 0.5 ETH. And I'm going to open an incognito window to get another burner wallet. And from this account, I'm going to stake 0.5 ETH again. So the balance is 1 Ether. I should be able to call execute. Also, we can just use the staker UI, which is basically the same. It just shows that we're good. We reached the deadline. We have also like a simple stake 0.5 Ether. So it shows that I staked 1 Ether. And that other guy also sold like 0.5 Ether. So we're at 1.5. I should be able to call execute. And we get this nice success message that we were able to reach the goal and send all the money to the external smart contract. If I try to execute again, I should just get an error message that staking was already successful. Also, if I just try to withdraw, it says that it's not open for withdrawal, so there's no way to to withdraw, and actually there is no balance to withdraw also. Also, if I just try to keep using the smart contract, even though it was like successful, and I just want to stake some more ETH, I will also get an error message that the staking was already successful. So this smart contract, I think, is kind of ready. What you can also do is there are tests written for this challenge. You can hit yarn test. And it runs 5 tests, and all of these tests are passed. So actually, there should be a lot more testing, but let's pretend that we're good. We tested our smart contracts through the UI. We run all the tests, so we should be good. I think the next step could be, instead of working on our local blockchain, to deploy to a public testnet called Sepolia. But for that, I need a deployer account. I can create a deployer account with the yarn generate, and I can test yarn account. With yarn account, I will see this address and all the balance, which is going to be 0. And I'm going to fund this deployer account with my Punk wallet. I'm going to send. So this is just test ETH. And if I hit yarn account again, then I should see that my Sepolia balance has went up, but it's not there yet. Let me try it again. Also, we can use the Sepolia Etherscan to check on our deployer account. And yeah, it shows that I have some balance. So I will be able to deploy my smart contracts to Sepolia. I'm going to edit the hardhat config TS file. And instead of working on localhost, I will point this to Sepolia. So I can just hit yarn deploy. And instead of deploying the smart contracts to my local chain, this will show up on Sepolia. It takes some time. So also I will start to ship my front end, which will probably also take some time. There is a scaffold config TS file, which points to hardhat, which is basically localhost, and I'm going to change this to Sepolia as well. My contract is still being deployed, and I will use yarn Vercel to ship my app. It will take some time. Let me check how my contracts are. So it seems to be, it was successful. Let me check. Yes, you can see that this deployer account has like 4 transactions. I funded with some ETH, and there are 2 contracts created. One really nice tool as well is that if I just try to open this contract and go to the contract tab, I only see the bytecode, and probably people won't really interact with this smart contract if they don't know the source. So we can just verify the source with yarn, with yarn verify. So if I come back to the Etherscan again, then I can see that actually my contract was verified, and I can see the source code as well, which makes it a lot more easier for other people to look into what's happening here. Oh no. And yeah, this is the Vercel build. It will take like 2 or 3 minutes, and we will get our front end shipped to a public URL as well. What I wanted to also show you is that how you can submit this challenge. So if you after this you go home and you start working on these challenges, you will start with the NFT challenge, and then you will follow with the decentralized staking app. I'm gonna connect through Wallet Connect if it works. Oh no. Let me open an incognito window because I already solved these challenges. So I will need just a new account. This is I will use Wallet Connect, which is a nice way to connect wallets and dApps. And I'm just gonna spin up Punk wallet, and I have a new burner wallet, and try to connect in. The first thing you need to do is just hit this register button. You can use MetaMask or any other wallet. It will just ask you to sign a message, with which you can basically prove that you own the account, this specific address. And once you have that, you should be able to submit this challenge. I just need the deployed Vercel URL and the smart contract from Sepolia Etherscan. I already have the staking contract. Which one is it? The staking contract here. Oh no. So this is going to be the contract's URL, and yeah, actually the app should be visible here. Let me just check. Oh no, so many tabs. So this is a public URL, and we should see the same app we built on localhost, but anyone could reach and connect their wallet. So in order to submit this challenge, I have the URL for the front end, I have the URL for the smart contract, and I can hit submit, and hopefully it will go through. It's just loading. Oh, okay. So actually, I need to sign this message as well in my wallet. And now it says that challenge submitted. It should take only like a few minutes, and there should be, the status should be changed either to, oh, it's already accepted. So actually, this was the decentralized staking app challenge. I would like to encourage you to go to SpeedRunEthereum and try to solve it on your own. And if you have any questions, let me know. Otherwise, Kevin will follow up with the next challenge. Thank you.
Any question for Tam? Yeah, sure.
Can you tell us about the example external contract that you created? What is it for?
Sure. Right now, it doesn't really do anything. So this is just a test. So that ETH we send to that example smart contract actually just stays there forever. So if you would like to create a proper staking app, you should make sure that the funds are actually sent to a proper address or a proper smart contract or to a person.
To buy, right? So that second contract would be like you buying an NFT. It's just like that.
Other question, maybe? Oh, you're good. Okay, thank you so much, Tam. That was great. And we have Kevin, yay, for the next workshop. So we'll be the next phase of the same SpeedRun Ethereum suite of workshops. And we have Kevin Jones that some of you might have met this morning. He did an amazing introduction about Ethereum and the technical aspects of Ethereum. And then he will now do a workshop on Ethereum. So yeah, please welcome Kevin Jones again for this amazing workshop to come. Yeah? Okay, oh yeah.
Testing 1, 2. Oh, that's good. All right, got your attention. What's up, guys? Thank you so much, like everybody, for being so like dedicated today and staying the whole day. Really, really appreciate that. So I hope you guys are learning a lot, and I hope this has been, you know, really helpful for you guys to understand more about, you know, how you guys can get involved. So we're gonna basically continue off with the challenges from where Tam went off. If you guys go to SpeedRunEthereum, at some point you guys need to get a wallet. So I already have MetaMask installed. So we can actually come in here, connect the wallet, use MetaMask, and then now we're signed in here. So challenge 0 is actually really easy. Like anybody can do it. It literally takes like 20 or 30 minutes. So I would give that as your guys's like goal today, is try to do this. Try to find like 20 or 30 minutes to sit down and figure this part out, because it doesn't really involve any coding at all. You guys can just walk through it. It's really easily. Obviously, the staking app you guys just saw is a little more complicated, and also goes for the token vendor. The token vendor is definitely a little bit of live coding. But at least you guys have an understanding of what you need to do. So we're going to focus on the token vendor today. So we can click that. Oh, and actually we want to connect to a different one. Let's connect to this one. How do I? There we go. Okay, cool. So when you first, you guys might not have seen this, but when you first connect your wallet, you can register as a builder. So you can just click this little register icon, and that will kind of create you a SpeedRunEthereum account. And then, you know, we've been talking about this all day, but everything you do involves signing a transaction. So what you do is you send a message here and you say, I want to join and register as a builder, and you give your public address and you sign that. So that will actually creates you an account, right? In this open way, anybody can do that, right? And then you have this little punk wallet, which is really awesome. And then you have a portfolio as well. So you can come here, you can add your social media contacts, and you can see all of your existing challenges that you've worked on. So we're gonna start and do a challenge, right? And then we're gonna be focused on this one here, which is the token vendor. Now, once you get through these 3, right, you actually get invited into the build guild. So your profile gets upgraded. So that would be my challenge for the next like couple weeks, is try to get to that point as well. Okay. So what are we going to be building today? So let me kind of zoom out a little bit. Actually, maybe that was better. So the cool thing about smart contracts is they're kind of like vending machines in the ethos of Ethereum. So this is really cool because you can interact with the vending machine to do whatever you want. And so what we want to do is create a vending machine that allows anyone to go to and be able to buy tokens. So basically we want to create a token vendor, right? So someone can come, send some ETH into the contract, and then get back some kind of token, right, in exchange. In this case, we're going to be calling it gold. So I love gold. So we're going to be focused on that. And we are going to utilize what's called the ERC20 standard for that. Now, if anyone has ever heard of Open Zeppelin is a security company for the Ethereum, well, for multiple blockchains, but more specifically for Ethereum, they've created these token standards. So we're going to use this ERC20 token standard, which is basically just a token for Ethereum. And we're going to mint some tokens. We're going to be able to edit our front end so that people can come and buy some tokens. And then we're going to publish this and then make it available. So similar to what we did before. So the first section is just going to be setting up Scaffold ETH. So if you are not familiar, we've seen it probably a couple times now that we've gone through and set up Scaffold ETH. In this case, we need to clone the scaffold ETH challenges repo, right? And in this case, we're going to go into that directory, and then we're going to check out this particular branch. So the challenges repo has all the challenges in it. So you can actually go through and look at all of them, but we're going to be focused on the second one, which is challenge 2. And then we're going to do a yarn install. So now I'm using what's called TMUX, which is a terminal multiplexer. So that's why you see these 4 windows. Actually, I'm going to get rid of 1 window, so you just have 3. So everything you do in Scaffold ETH, you need a few windows open. So I've gone ahead and I've already checked out the repository here. Sorry, I know that's hard to read. But if I do a git branch, we can see that I'm on the challenge 2 token vendor. And I've also went ahead and did the yarn install, but you'll need to go through and do that. I just went ahead and did it to save some time. So after you have that up, so it's always the same kind of commands. First, you're doing yarn chain, which spins up your blockchain, right? Very simple. That's going to spin up all of those play accounts with the ETH and stuff like that for you to play around with. And then I'm going to go to this second window. I'm always going to have that one open, right? And now I'm going to do yarn start. So this is all in the same directory. So I checked out a directory called C2. So we can see that we're in there. And we can see help as well here, git branch. There it is. So now I'm going to do yarn start. So that's going to spin up the front end. So you always do those 2 things, right? And then you keep those running. And the nice thing about TMUX is it just shows you. I would look at TMUX later. You don't have to do that for today, but it's really helpful. And then the last one is that we're going to do that deploy. So we're just going to go ahead and deploy whatever contract is there, just so that it's deployed. And we're just going to make sure that it deploys successfully, which it did. So it tells you that you deployed it successfully. It tells you how much gas it cost, which is really useful, and it tells you the contract address. So now we know that we've kind of gone through this environment setup, right? With all those commands: yarn install, yarn chain, yarn deploy, yarn start. We've got everything working, right? So now we can load up the app. So again, Scaffold ETH runs on localhost 3000, port 3000. It's React with Next.js. So we got everything up and running, and it's working. So we have the debug contracts tab, which is here. And we have, it's a little slow for some reason. I think the internet's kind of acting up a little bit. So it might be a little slow. Let's see. Okay, that was very slow. It's not normally that slow, I swear. But we can see here that we have a contract that's already deployed, and we can see that it has some details, like it has a name, it has decimals, it has the gold GLD symbol, and it has a supply of 0, because we haven't minted any. But let's go ahead and load up the project and take a look at it. Okay. Okay. So, so here we have just the standard Scaffold ETH project. Inside the hard hat folder is where we're going to spend most of our time today. And then inside the contracts folder, we have 2 different contracts. We have a vendor, and then we have a token, right? So the cool thing is you can deploy contracts, and you can inherit contracts and kind of connect them together. So that's kind of what we're going to be doing in a little bit here. But I want to just go through the first kind of steps that it's going to ask us here on the token. So the first thing it's going to say is like, okay, you need to edit your token file, the Solidity file, to basically inherit ERC20 from OpenZeppelin. And then we want to also mint 1,000 of our tokens times 10 to the 18th power to our front end using the constructor. And then we're going to deploy that using the reset command. After we do that, we should be able to see the balance, and we should be able to transfer stuff around if we want to, okay? So how do we do that? Well, it's actually very easy, because we've your token Solidity file that comes with this project actually already has the ERC20 imported right here. Let me go up a little bit bigger. So we already have it here. Now you'll see that this particular package comes with the ERC20 solidity file that lets you create a token. So when you import this token like you do here, you can then inherit the token inside of an existing contract. So you can see here that we have a smart contract that's called your token. And you see this little is right here? So this says that this token is an inherited token from this standard or this existing implementation. So basically we're saying, okay, like create this new token, use the ERC20 that's referenced here, and this will get you access to all the variables, functions, modifiers, basically everything that's inside here is going to be available to you in this contract. So that's really, really powerful because this contract is kind of like certified as being a trusted and, well, Turing complete, I guess, or feature complete contract. So we can see that we already mint, well, we already create the name of the token. So it's called gold. And we have the symbol, which is GLD. But what we need to do is actually mint the tokens. So we actually have it already written here. So we can just uncomment that out. But what this is going to say is like, okay, well, we want to mint these tokens to an address that we specify here. So what we'll do is we'll grab our burner address here. So we have a burner wallet, right? We don't have to worry about MetaMask right now, but we already have that here. Copy address, and we can paste that in here. So what this is going to do, so underscore mint is a function inside of ERC20. So we can call mint, pass in an address, tell it what quantity we want. So we want 1,000 times 10 to the 18th power because we want to get 1,000 of these, but we also want to get them in full like way, right? So we have a larger amount. We can break it up, you know, into smaller increments. Okay. So all we need to do is save that, and then we can do a deploy -- reset. Okay. So that's going to take the contract, going to redeploy it, and you'll notice that we get a new address. So before we had this address here, now we have a new address for the contract, which is here. And we can also see that the gas increased too. So we went from 564 to 614,000 gas. So as we start adding to our contract, the gas increases, okay? But at this point now, we can come to our app, we can grab the address again, and we can check the balance of this address, right? If I check the balance there, cool, it says 1,000. I have 1,000 these tokens. But I also could check Vitalik.eth, and I could see if he has any tokens. Oh, why is that not valid? I think it's because the internet's not working. There it goes, okay. So he doesn't have any tokens, but I have them. I'm more rich than Vitalik. Okay, so you get the idea. We've created, now this total supply has changed from 0 earlier to 1,000. So now I have these 1,000 tokens. So we kind of know that we're moving along, right? We set up the environments. We created a mint. So we minted these tokens. We can balance them. We can also transfer the tokens. So if I want to pull up an incognito window like this and go to localhost 3000, I can get a new burner wallet. And I could transfer some tokens if I wanted to by sending to this one if it loads. I'm not sure, but the internet is just slaughtering this demo a little bit. Oh, 4,000 milliseconds. Okay. Okay, well, that's okay. But we'll see if that loads in a little bit. Otherwise, we'll keep going. Okay. So if I wanted to, I could actually come here and I could transfer some tokens right here. But you can see that when we imported all of the, we imported the ERC20 standard, we get access to all of the functions that are in there, right? Which is really useful. And there's also modifiers as well. But it's really cool because we can start exploring to see what functions are available. So let's keep going. Okay, so now what we want to do is we want to create a vendor, right? So what does a vending machine do? Well, it takes in cash or fiat, or in this case, ETH, and then it gives back something. So we want to give back some tokens. So we need to set basically like a price variable for how much our tokens are going to cost per ETH, right? So that's the first thing we want to do is say, okay, we want to say that in this case, we will define a variable for the vendor. So this time we're kind of done with the token. The token doesn't really have much function other than just minting the tokens. And we'll probably have to change this in a little bit. But for the most part right now, we're just going to focus on the vendor from here on out. Let me zoom this over a little bit. Okay. So the vendor is very similar, but it's not an ERC20 token. It's just a standard kind of smart contract. But what's important is we're actually inheriting the existing token address from the other contract, and we're also importing it like this using just the Solidity file. And then we just have this like very basic vendor. So what we can do is we can define a variable inside of the contract. So in this case, let me just reference this to make sure. Yeah, so we want to just drop it basically in here. So we're going to say basically, okay, for so this is an unsigned integer. The 256 is like the size, the max size of the integer. So you could actually lower this a lot more if you wanted to. You could do like 128, you could do 64. Just for the sake of thing, you always want to put what it is. You could also just do uint, and it would just give you the max, which is 256. But we're going to just do uint 256 because that's kind of best practice. We're going to make it publicly available. We already talked about that. That means that it can be accessed inside of the contract or externally. It's a constant, so we don't want it to change. And then we just want to call it tokens per ETH, and then we want to define 100, right? Okay, so we can do that. We can save that change. And then what we want to do is import ownable next, which I think it's going to ask us to do that. So at some point, it's going to ask us to do ownable. So inside of smart contracts, every smart contract needs to have some kind of pattern for access control. So if you're going to store ETH inside of a contract, you need to find a way to get it out. Because if you put it in and you don't have a way to withdraw it, it will be lost forever, right? So what's cool is Open Zeppelin, again, has created a set of contracts called the ownable contracts, or the ownable contract, I should say. And it's right here. So we can import that like this, and we can say that your vendor is ownable. And what this is going to do is it's going to give us an access control pattern for our contract so that later on when we want to withdraw funds from the contract, we can check to make sure that someone is the specific owner. Okay, so let's save that. And let's try to deploy. Let's see if it works successfully. Okay, works successfully. Okay, so what else is it going to ask us to do? So, so we want to create the buy tokens function that's already available in the vendor. It says that it should use the message value and the tokens per ETH to calculate the amount of tokens that you should transfer to the sender, right? And then we also want to, it's going to ask us to emit an event. And then it's going to ask us to update the deploy script so that it deploys properly, okay? So for this, what we're going to do is we are going to, let's see here. So here we want a creatable payable function. So in this case, that's the withdraw function. Okay, so we want to do a function. We want to call it buy tokens. And we want to make this function public and payable. So publicly available, payable is so that it can receive funds because we need to actually send some ETH there. So the function is called by tokens. It is public, which means anyone can interact with it. One of the first things that you'll learn with Solidity is that you can create require statements. You guys probably saw this earlier, but we want to basically require that whoever is interacting with this particular function actually is sending some value, okay? So the first thing we want to do is get the message.value. So we might have talked about this earlier, but there are what are called global variables that are available during a transaction. One of those is the message value, and one of those is like the message sender. So message value is how much actual ETH is being sent in the transaction. Message sender is the public address of who called that. So we're going to say, okay, in order to call this function, you actually need to have sent more than 0 ETH. Otherwise, you need to send some Ether. And then we're going to set the amount. So uint 256 amount equal message.value. That. And we also could, I mean, we could do this a little bit different, but we could also do it like this. We could say uint 256 tokens equal amount. God, I love AI. It's making so much easier. So what we're going to do is we're going to say, like, what was the amount sent in the transaction? And we get that from the message value. And then how many tokens should we actually mint based off of that amount? So the way that we get that is we can say the amount times the tokens per ETH, which is defined here. And then that will give us the amount of tokens. And then we can also do uint 256, get the token balance. So your token dot balance of, and then we want to say address of this. I think that's right. So then this is going to get the current balance of the smart contract. So basically what we're going to do is we're going to load the contract up with all of the tokens that it needs to be a vendor. And we're going to allow people to withdraw from that your token or purchase from that contract. So we need to be able to get the balance. So this is, I'm doing this in a very like explicit way so that you can kind of see these different ways that you can interact. There's probably a more optimized way to do this, but at least you can kind of get an understanding of what that looks like. The next thing is we can do a require statement to basically check to make sure that there's enough tokens in the contract to be purchased, right? So what we can do is say require that the tokens, there we go, require that the token balance is greater than or equal to the amount of tokens that need to be purchased. Otherwise, there's not going to be enough tokens in the contract. And then last fee, we'll figure out who the buyer is. So we say address buyer is message sender. And then now we can do the transfer. So what we want to do is we want to call the transfer function of the existing your token, right? And we want to pass in who the buyer is. And then we want to transfer the actual funds if it was successful, right? So we can do something like this. And we can do the same thing that Tam did, where we can say Boolean success, or let's call it sent, just to stay consistent, and then like this. So basically, if the transfer is successful from your token, then create that variable. And then we can do a require statement that says sent, otherwise failed, something like this. Yeah, that should work. Okay, so this, let's walk through it real quick. So we're going to say, all right, require that the person is calling this function has a value of at least 0 in the transaction. Otherwise, they need to send some ETH. create a variable that's the amount, which is the value, calculate how many tokens that they're going to be able to get after they've sent that, check to make sure that the balance of the token has enough tokens. If it doesn't, then say there's not enough tokens. And then on top of that, figure out who the buyer is, and then send those tokens by doing a transfer call on that other function, right? And then pass that. And it's only going to work if the Boolean is successful. Otherwise, it would be like failed transfer or something like that. Okay? Okay, so that should work. The last thing I want to do is also talk about the event. So we want to create an event. The cool thing is the event's already written for you here. So we can just uncomment this one. And we can see here it's called buy tokens. So like I think the best practice is to capitalize the events. So in this case, it's buy tokens, capital, which is the same as the function. And what an event does is it just passes some information, emits that information so that your front end can see it, other protocols can see it, block explorers can see it. It's pretty much anything important that you should log or you want to log, you put into an event. So in this case, we want to log who the buyer was, how much ETH they wanted to buy, and then how many tokens, sorry, how much ETH they deposited and how many tokens they got back, right? So we can keep track of that. So I think this should be good. We just need to emit the event. We can do that later because I think it's going to ask later. We could also do just while we're here, we can create a sell tokens event because I know we're going to need it. Address, oh, that's not useful. Seller, UINT 256, amount of ETH. And then UINT 256, amount of AI is not helping me because the internet probably is messed up. Okay, so let's just try to deploy this and we need to actually update the deploy script too. So we've made all these changes, but we actually have, with Scaffold ETH, for every contract you have a separate deploy script, okay? So we have the vendor and we have the token. So the token we don't need to change because it's pretty much good to go here. But the vendor, we need to actually make it deploy the vendor. So as of right now, it's not deploying. So you can see here that it's actually already written for you. So you can just grab all of this stuff and then uncomment that out. So Hard Hat uses TypeScript basically to do a deploy, or JavaScript, depending on which version you're using, how you have it configured. But we want to use all of this code, and it's, like I said, it's already written for you. I think what's most importantly is that we use the deployer account that comes with Hard Hat to deploy the contract. That's kind of a good thing to know. We also pass arguments here to get the token address. And we also do a transfer to transfer some ETH to the vendor address. So we actually need to put our front end address here to also transfer ownership of the contract. So what I want to change is two things. First is I want to mint all the tokens to the message.sender instead of the front end address, because we want to actually send the tokens to the deployer account first, and then we want to physically transfer them to the vendor. So it's kind of like a two-part thing. So the tokens will be minted here to the Hard Hat account, and then they'll be transferred later on to the vendor so that people can buy them. Okay, so let's save that. Oh, save, make sure everything's saved. Okay, this is saved. And now we can put our front end address here. So let's grab that. I hope this is gonna work. Okay, front end address. Boom. Okay. It's kind of weird. Sometimes you need quotes, sometimes you don't. In the case of TypeScript, we're putting that in quotes. If you're using Solidity, you don't use quotes. That's generally. Okay, let's try to deploy it now. Fingers crossed. YOLO. Oh, what did I do? Your tokens, buyer tokens, inside. Something with the vendor. Your token, about transfer. Oh, maybe. Oh, do we want to do message.sender actually here? And then get rid of this. Tokens. That should work, yeah. Let me try it again. There it goes. Oh, it didn't like the comma. You're right. Okay, cool. All right, the deployed. Thank gosh. Okay. All right, so now let's go and check out what we have here. So now we have a total supply of 1,000, right? But now if we check the, let's look at the thing here. So we have the ability, so when you try to buy tokens from the vendor, so I already kind of fixed that because I did a transfer here in the contract. We can look at it real quick. But here we transfer the tokens to the contract, and then we also transfer ownership of the contract. So I already fixed some of this stuff. But we should be able to now go to our thing. Let's reload. And we also need to open up, I believe, the front end so that we have access to buy the tokens. Let's see if it's available. I don't think it is. Token vendor. Okay, so we're missing the ability to extract the tokens here. So I think what we need to do is come into Next.js, go to the app, go to the token vendor, and just, I guess, retroactively, I'm going to go through here and like uncomment this stuff so that it's all there. Because basically they have you do this kind of one by one in the thing, but I think what I just want to do is just uncomment this stuff so that we have it available. So in this case, we're going to get rid of this. So these are all comments. So in this case, we want to just kind of get rid of the commented out stuff so that we just have all this available in our front end. Ideally, you like follow the documentation and kind of understand how this works. But I think at this point, okay, cool. So now we have this buy tokens function. So it says that we should be able to buy 100 tokens. If I've written the smart contract correctly, I should be able to buy 100 tokens per ETH. So how many tokens do I want to buy? Let's choose, I don't know, 2 tokens. No, probably more than that, 2,000 tokens. It's going to ask me buy tokens. It's going to tell me that I don't have enough ETH, right? Oh, there's not enough tokens in the reserve because I only have 1,000. So let's just buy 2. Buy tokens. And now it's going to tell me I don't have enough funds. So I need to get some funds from the faucet. So I can just click that. Now let's click buy tokens. And there we go. So now I was able to buy 2 GLD. And then I could also, now that I have the access to the tokens, I can also transfer them. So I can come over here and I could basically transfer them to this address. So I can grab this address here and I can say transfer to, send 1 over here, send tokens. Now I only have 1 token. Now if I come over to this incognito window and go to token vendor, this one has 1. So I've created this token vendor. I've been able to go in, send some ETH, buy some tokens, and then send them to my friend, right? So we got the buy tokens working. Cool, we're about halfway through. Now we need to do the sell tokens side, okay? So we have the ability to buy tokens. We've deployed the contract. We've minted the tokens, sent them to the vendor. We're pretty much good there. So now I think we want to focus more on the vendor again, and we want to do, we have 2 different things. The most important thing, I think at this point, is to create a function that allows us to withdraw, okay? So the main purpose here is we want to be able to get that ETH out or after the fact. So like saying at some point you want to take some profits on your application, well, you need a function to withdraw. So we're going to call it withdraw. Oh, if I can spell correctly. So function withdraw, we're going to make it public, but we're going to make it only owner. So cool thing about AI is it wrote it all for me. But what this is going to do is going to say, okay, I want to withdraw all of the ETH that's available inside of the contract. So it's kind of like a rug pull. So I'm going to create this withdraw function. It's only the owner can call it. So if you remember earlier, we inherited ownable, and we inherited here. What's cool about ownable is if we click it and look in here, there's a special modifier called only owner. So a modifier is kind of like a function, but you can have it run as a requirement, similar to like a require statement before a transaction is executed correctly. So we do this thing called check owner, which makes sure that the owner is the sender of the actual contract. So it's a way for you to do access control for, like, obviously we're dealing with real funds, so we need to be very safe in that sense. So we have this function that says, okay, anyone can call it, but you can only actually successfully call it if you're the owner. We get the balance by checking the balance of the contract. If the balance is greater than 0 or less than 0, then we can't withdraw. Otherwise, we will transfer the balance to the person or to the actual owner. We could also change this to like message.sender or something like that. But I think for the sake of this, I think this should be good. Actually, let's see if it works. Sure, let's do it. Is yarn deploy reset? Can I save it? Yep. Okay, so now I've kind of reset the contract. Let's buy some tokens. Let's buy 20 tokens. It was successful. Now I have 20 tokens. So there's 20 tokens in the contract. And I'm the current owner. So if I go to debug contracts and I go to, let's see here. Oh, maybe I can't see. Oh, yeah, here. Oh, your token. Actually, the owner is not set. Oh, there it is. Sorry. Okay. So I can see that the owner is 0xA4 right here. So I'm the current owner of the contract. So if I was to come over to this guy, this kind of incognito guy, and I see that there's some balance in the contract, right? I'm like a malicious actor and I want to withdraw that ETH from there. We want to make sure that I can't do that. So we did that. We created the only owner access control pattern. So now if I go to debug contracts, I can see there's some ETH there. So if I wanted to try to withdraw it from this account, it's going to tell me that I'm not the owner. See how it says ownable, caller is not the owner. But if I go to this particular contract and I go to withdraw, then it's successful. So I know that the access control works correctly. So that's really important. Anytime you're dealing with withdrawing funds, you want to have some kind of access control. Okay, so the next thing we want to do is focus on the sell tokens. Okay, so let's try to knock that out. So the last thing is to sell tokens. Okay, so we want a function called sell tokens. Same thing, we want it public. I don't think it needs to be payable, so we can skip that. We want to define a int 256, and we want to get the balance of the contract. So we could do token balance equals your token dot balance of, and then we can pass in the address of this smart contract like that. I think that should work. And then we can require. So we can require that the token balance is greater than or equal to the amount. Oh, that's the other thing, is we want to actually pass in the amount. So let's do that at first. So we want to say, okay, well, if someone wants to sell tokens, they're probably going to say how many tokens they want to sell. So we're going to say uint 256, and we're going to pass in an amount. So in this case, this function is going to take in an unsigned integer. And then we want to make sure that there's enough tokens to actually sell, right? Otherwise, we're going to pass this error. And then we want to calculate how much ETH that we need to basically send, right? So we can say uint256, in this case, amount is equal to underscore amount divided by tokens per ETH. So in this case, we're doing the opposite. We're not multiplying, we're dividing the amount of tokens per ETH. And we're going to also require that there's enough ETH to pay, right? So we can say require amount, require the address of this smart contract's dot balance is greater than or equal to the amount. Otherwise, we'll say, I don't know, not enough funds. There we go. Okay. So at this point, we're creating a sell function that allows us to make sure there's enough tokens to be sold. Make sure that the balance is there. Make sure that they can get the funds. I think that should be right. And then the next thing is we want to transfer the tokens to the contract. So in this case, we'll do your token dot transfer from, or actually it's just transfer from the message dot sender. Oh no, it's transfer from actually. Transfer from message dot sender, the address of the smart contract, and then the amount that's being passed, right? So in this case, we're going to do that. If it doesn't work, so if the Boolean doesn't exist, we can say failed transfer. And then I think the last thing is we need to like omit. Oh, we need to transfer the ETH. So in this case, we're doing the transfer from on the tokens, right? So this is doing the sender, the amount of tokens. And then we also need to pass in here. So let's do Boolean. We'll call it sent to, I don't know, yeah, sure. Equal payable message.sender. And then we'll do a .send, I guess, amount. And then we can do a require statement as well that requires sent to, otherwise failed to send ETH. Okay, and then the last thing is we created an event already. It's here, it's called sell token. So we can emit that event. So we can do emit sell tokens, pass in the message.sender, pass in the amount, and pass in the amount of ETH that's being passed back as well. Okay, I think that should be good. Are we emitting the event here as well? Oh, we're not. We should do that too. So buy tokens, so we should emit the buy tokens event. So in this case, it's buy tokens. This is amount tokens. Let's make sure that's right. Okay, that should be good. All right, let's save that and let's try to deploy. One. What did I do here? Address of this dot balance. Oh. That doesn't need to be there. Okay, let's try again. Oh, did I do the sent to sell tokens. Sell tokens. Did I name it right? Sell tokens. Oh, here. Okay. Some small typos, but I think I got them worked out. Whew. All right. All right, it worked. Okay, so now I should be able to go back into the app. So I've created the ability to buy tokens. We've showed that. Now let's go to the token vendor and let's refresh and let's get some funds from the POS just to make sure we have enough. So in this case, let's buy 50 tokens, right? Now I can buy those 50 tokens. Let's say that I want to transfer those to my buddy over here. So I can come over here, copy the address, and we're just kind of testing as we're going. Let's send him 25 of those tokens. So now he has 25. So now he should be able to come in here to the vendor, and then he should be able to sell those tokens. Now, when you're working with ERC20, you need to basically approve a transfer before you can actually do the transfer. So you can see here that we have this approve button, which allows us to call the approve function. So in this case, let's say that I want to just sell like 10 of my tokens. I can approve that I only want to sell 10. Approve. Oh, I need some gas. Okay, let's try that. That's weird. It's a UI bug. All right, 10, approve. There we go. So I approved the sale of 10. Now I can sell 10. Sell tokens not found on ABI. Oh, maybe I didn't name something correctly. Let's see. Oh, I didn't do the function name correctly. So let's save that. Let's redeploy. So this is kind of how you do it. You start tinkering and toying around. Okay, so now I should be able to do that again. I'll just do it. This time I'll just do it from this account. So let's buy 50 tokens. It worked. Let's approve the sale of 10. Approve. And then now let's sell those. There we go. Now it was successful. So now I have 40 tokens. So I bought 50 tokens. I approved the transfer of 10. And then I sold 10. And I still have 40, right? And now the contract has half of an ETH. So now I could pull that stuff out by coming to debug contracts and do a withdraw. And then I get all that back into my wallet. So now everything's working. The way we can check is to do the test. So let's do that. Yarn test. So this is going to run hard hat test. And it's going to make sure that it passed. And it did. Okay. We're success. So it passed all the buy, sell, withdraw, the approve function, the transfer function, and the vendor and the your token are all working correctly. The block limit's set. It's enabled optimizer. We're good. We're good. Okay. So the next thing we want to do is deploy it. We just went through this again, but let's do it again. We're going to do, so we need a deployer account. Like we want to put this on a test net, right? Let's just make sure I did everything first. Let's go here. We came in here. We did ownable. We did the vendor buyback. Everything's working. Now we want to deploy the contract. In this case, what we're going to do is we're going to deploy it to Sepolia. We'll use Sepolia again. So what we can do is yarn account. Sorry, that's not correct. Yarn run generate. So yarn run generate is going to generate us a private key and a public key, and it's going to store the private key inside of our directory in the environment variable file here. But we have a public address. So we could do yarn account, and I could pull out my Punk wallet, and I could fund it. So let's send some Sepolia ETH. See if I can do that. Actually, you know what? I'm just going to do it the easy way. I'm just going to grab the address here, and I'm going to send some from this wallet here. So I have, oh, I already have some here. So I have 1 ETH. So I'll send that. I'll send it to that address, and I will send 0.2 ETH next. So I'm taking some funds that I have in my MetaMask, sending them to that deployer key. So now that should work. So now if I do yarn accounts, it's going to go through and check my balances, right? There we go. All right. Sepolia is working. Okay. So I was able to send some funds to that deployer. So now I can do yarn deploy -- network Sepolia, right? So what that's going to do is take my contract, compile it, see if it needs to compile, which it didn't. Then it's going to ship it to Sepolia by doing a create, basically. And very slow, but that's okay. We'll give it a second. And it's going to deploy that. The next thing we need to do is get our front end ready. So while that's doing that, let me open up, be able to get chain ID. Okay. While that's doing that, I'm going to go into the C2 directory here, and I'm going to do a yarn, was it Vercel YOLO -- prod? Is that what it is? Oh, wait till the contract's done. Oh, yeah. Thank you. Okay, so, it's deploying both the contracts. I hope it has enough gas. So if it doesn't, it's going to tell me, but I think it's good. 0.2 ETH, we're good. Okay, cool. So that was successful. So now our contract has been shipped to Sepolia. So we can update our front end. So we go back down in here. We can go into what's called the scaffold config. You probably saw this earlier. Let's chain the chains to Sepolia, like that. We could also update some stuff here, lower this. What is this? This could be false. That's a good one. Okay, so now we can load up the front end and make sure that it's showing the proper contract. Okay, so there it goes. It's deployed to Sepolia. We can click it and see. Okay, while that's doing that, I'm going to do a yarn Vercel YOLO -- prod or dash prod. No, let me just get it here. Oh, great. Oh, here it is. Yarn Vercel -- prod. Okay. Okay. Yes. Boom. Yes. Okay, it's uploading. Okay, so let's see if the contract worked. Okay, so it was deployed successfully a minute ago. One thing you'll notice is that on the contract tab, we have the bytecode here, right? We talked about bytecode today. It's unreadable. So you should also verify your contract. I don't know if Tam did that, but I'm going to do that real quick. So how we do that is we just do yarn verify -- network Sepolia, because we need to, well, we need the contract verified. Yeah, so Tam would have had to have done it in order to get the results back from Bill or from SpeedRunEthereum. So now it's verifying my contract. So when you verify the contract, it's basically comparing what you deployed to what your source code is to make sure that they match, so that people have an open view of what your contract does. Because you don't, you want to operate in an open way. This is an open source conference. So that's why we verify our contracts. And there we go. So it's working, verified. So now if we come here and refresh, we'll get the verified contract. You can see all the code that I wrote here. Here's the ownable contract. And here is the ERC20 and the token and the ABI. So everything's good. The last thing we need to do is just make sure that that ships appropriately, which it should be good. But in the meantime, let's grab this and let's try to let's see if it passes our test. So we can go submit challenge. So we can do here. And then this might take a second. While that's doing that, it looks to me like we have like 10 minutes. Oh, here we go. Okay, so production. I don't know if it's going to work yet, but we'll try it. Let's see. Submit. It's going to ask me to sign my transaction. Sign. Cool. Deployed, submitted. And at some point it should verify it, but we did it. We deployed the app. So I have like 5 or 10 minutes for questions. So I guess at this point, I'll open it up to you guys and see if you guys have any questions about that. Got to be at least one question. At least one question. Come on. Otherwise, we'll take a little bit of a break and then we'll do the data indexing. Did you?
Yeah.
Did Did I miss something?
No, not at all. You did a great job. You were talking about how smart contracts have different role-based systems. But I would also add to that the best smart contract doesn't have an owner, right? The best kind of smart contract is like algorithmic and doesn't have any way for anyone to be able to pull any money out. And it works in a different way where they pull the money out based on the rules of the system and not if they're the owner or not.
Yeah, that's a good way. That's a good point. Yeah, I think we try to build things in the ecosystem that are like game theory, interesting, cool apps. And so, yeah, that's the power of smart contracts is you can just kind of let go and let them do their thing. And you can build some really cool stuff with that.
Telegram channels. As you're doing these, there's a Telegram channel.
That's a great point. So for every challenge that you go through, there's a specific Telegram channel that you can get support for. And I think it's just down here at the bottom. Yeah, here it is right here. No, it's somewhere here. Problems, questions. Here we go. So we have this. So we have the Scaffold ETH main developer chat. So if we click that, that will take you there. There's also, I think there's a link on the top. Yeah, Austin? Oh, here it is. There's a special Telegram chat for every single challenge. So you can go into this, you just click it. It's going to load up your Telegram, and then it's going to invite you to the group. I won't open it, but yeah, so do that if you get stuck. If you just have general questions about Scaffold ETH, you can just go on to the main Telegram chat. I'm not sure if anyone talked about it, but the Scaffold ETH IO, there's a docs that's really, really good. We didn't really get into that too much, but I think in here, like anything you want to know about Scaffold ETH, all of the components that are available. So there's an address component, balance component, inputs, any of the ways you interact. So the hooks are all here as well. So if you want to read from your contract, it gives you an example. If you want to write to your contract, if you want to subscribe to events, this is how you would do it. If you want to see all the history of events, if you want to just get contract info, whatever, there's all documented really well. So yeah, the docs are great. If you have any questions, we'll be around for a little bit. And yeah, any other questions?
Cool. Okay. Thank you so much, Kevin. That was amazing. Yeah, great workshop. We have a little surprise because we are very lucky to have Loy with us, Loy from Kyber. He's an OG in the space. So we had a break plan, but I think we would like him to have a few words. That will be in Vietnamese, by the way. So please welcome Loy. Yeah.
I'm gonna use Vietnamese. Anh sẽ nói tiếng Việt nhá, nên bọn em ở lại nghe một tí thôi. Rủ thêm mấy bạn nữa. Sorry guys, time for you to check the AI translation. Yeah, hopefully. Yeah. Okay. Ở đây có những bạn nào đang là sinh viên của công nghệ thông tin nhỉ? Computer science. Okay. Anyone doing like hardcore programming? Có bạn nào mà học kiểu lập trình competitive rồi thi ACM các kiểu không? Oh wow, okay. Cool. Thế các bạn còn lại là học cái gì? Chưa nghe rõ. Mấy bạn này là học gì? Kinh tế, okay. Economics, computer science, okay. Còn ngành nào nữa không? Ok, giới thiệu với mọi người một chút. Anh tên là Lợi. Anh trước anh cũng học ở Đại học Quốc gia ngành khoa học máy tính, Đại học Công nghệ của Đại học Quốc gia ngành khoa học máy tính. Và sau đấy thì anh có sang Sinh làm PhD cũng về computer science. Và bắt đầu là nghiên cứu về blockchain, về Ethereum, về Web 3 từ 2013-2014. Đó, thì nói chung là cũng có một cái khởi điểm hơi sớm so với mọi người. Lúc đấy mà kiểu tất cả mọi thứ nó vẫn mới chỉ bắt đầu thôi. Lúc đấy mà ước gì là sẽ có được những cái kiểu workshop như thế này. Đó, để các anh ấy dạy mình lập trình rồi làm sao là có được những cái documentation các thứ nó đầy đủ như thế này. Đó, nhưng mà Hồi đấy là toàn phải tự mày mò thôi, toàn phải tự lên forum rồi những cái mailing list các thứ để tìm hiểu. Thì hôm nay rất là vui là thấy được Ethereum Foundation và Arbitrum và tất cả những cái gọi là the best Web3 brands có thể đem được một cái chương trình, một cái workshop hữu ích như thế này đến cho tất cả mọi người. Các bạn không thể biết được là làm cực kỳ khó để có thể mời được tất cả những speaker như thế này và chạy đến những cái workshop mà bài bản và rất là chi tiết như thế này. Và mình rất là vui là nó diễn ra ở Hà Nội và đặc biệt là một trường mà cũng khá là nổi tiếng về các ngành thiên về khoa học kỹ thuật như là Học viện Bưu chính Viễn thông. Ở đây thì có những bạn nào đã nghe về Web3, nghe về Ethereum rồi các thứ rồi trước đấy? Ok, 1, 2, 3, 4, 5, 6, cũng thực ra cũng không nhiều. Thế thì chắc là hỏi một chút đi, coi như là để kích động các bạn một chút. Mức lương mà các bạn mà expect là khi ra trường sẽ là bao nhiêu? Dưới 1.000 đô? Dưới 1.000 đô? Ok, từ 1.000 đến 2.000. Ok, nhiều hơn rồi. Từ 2.000 đến 4.000 đô một tháng. Thế các bạn không giơ tay là không đi làm à? Không muốn đi làm luôn à hay như thế nào? Ok, thế thì dưới 1.000 đô là bao nhiêu người? Ok. Thực ra khá là nhiều. Thực ra thì anh thấy là Web3 nó là một cái gọi là open, một cái thực sự là một cái global movement á. Thế nên là nếu mà bọn em có thể là cố gắng là catch được cái development này rất là sớm. Thực ra nó có rất nhiều những cái vị trí mà mình không phải là chỉ cần là không phải là bắt buộc phải là computer science hay là công nghệ thông tin gì ấy để có thể tham gia, mà nếu mà chúng ta có thể là thực ra nó có rất nhiều những cái vị trí nghiên cứu khác. Đó, chẳng hạn như là kinh tế học hay là làm về finance, làm về community, làm về những cái development như thế này, đúng không? Thì chúng ta đều có thể tham gia được. Và thực sự đây là nó là một cái gọi là một cái ngành nó đang phát triển và rất là sớm và đang thiếu hụt rất là nhiều talents. Nó cũng giống như là những năm 2009, 2010 mà chúng ta bắt đầu học về công nghệ thông tin ấy, thì thời điểm này mà chúng ta học về Web3, về blockchain rồi các thứ, anh nghĩ nó cũng sẽ là đón đầu cái xu thế trong tương lai thôi. Thì lúc đấy mà khi mà chúng ta ra trường ấy, thì cái việc mà kiếm được những cái công việc và làm việc cho những cái tập đoàn lớn, những cái tổ chức lớn ở quốc tế mà lương từ 1-2-3 nghìn là cái chuyện mà hoàn toàn bình thường. Và thậm chí là các bạn mà anh biết nhiều bạn mới chỉ ra trường khoảng 2-3 năm, lương các bạn có khi lên đến cả 10.000 đến 15.000 đô một tháng. Đó, thì đấy đều là những cái mức lương mà mình không tưởng được luôn. Đó, thế nhưng đây đó là một cái gọi là thực sự là một cái global movement, nó như kiểu là the new internet ấy. Đó, nó là một cái internet hoàn toàn mới, nên là nếu mà chúng ta cố gắng đón đầu được cái xu thế đấy, chúng ta học được từ the best, từ tất cả những anh chị ở đây, thì nó sẽ là một cái điều rất là giúp ích cho tất cả mọi người. Thầy là ở bên trường. Ok. Any question? Có ai có hỏi gì không? Okay, there's a question over there. Em cứ hỏi đi. Okay, he's from what's that, like embedded system kind of, right? And he's asking like whether there's any like interesting position for him in Web3. Anyone want to address? Okay, maybe you can have him answer the question.
What is the question?
He's not from computer science. He's from more like embedded system, electrical engineering and things like that. Is there any like position for him in the space in Web3? Yeah.
Yes, actually, some knowledge of embedded system can be useful in zero knowledge proofs and such that I'm going to talk after, and learning also about circuits, and there is all the things about optimizing opcodes in the bytecode of a smart contract that is very related to what you do sometimes in embedded systems. So yeah, I think definitely this is deep tech, and I think like knowledge from other deep tech branches are going to be very useful.
Ok, anh ấy nói là khi mà nó có rất nhiều những cái gọi là programming mới gọi là low level ấy, hoặc là những cái design mà hiện nay trong crypto vẫn đang trong blockchain vẫn đang phải dùng rất là nhiều. Thế nên là khi mà em học được tất cả những cái basic theories như thế thì sẽ đều apply vào được cả. Nên là nghĩa là làm sao mình chủ động mà mình pick up và mình xem là những cái gì mà chẳng hạn như là bên blockchain đang cần thì cứ nhảy vào mà học thôi. Có một cái rất hay ấy là anh thấy cái blockchain community là cực kỳ mở, nghĩa là làm sao em cứ có được cái câu hỏi thì sẽ có một ai đó sẽ trả lời cho mình. Mà đây là mình giao tiếp với cả the global community luôn. Nên là không cần phải lo là sẽ thiếu người giải đáp hay các thứ gì cả. Cái hồi mà bọn anh bắt đầu từ 2013 là gần như là thậm chí là chỉ có một vài cái forum nhỏ nhỏ mọi người mới trao đổi trên đấy thôi, nhưng mà mình vẫn lên đấy mình trao đổi tích cực thôi. Sẽ có những người khác người ta contribute vào. Yeah. Ok, câu hỏi nào khác không? Any other question?
Dạ thì em đang có em cũng có định hướng là sẽ theo ngành web 3, cụ thể là developer cho mảng blockchain luôn ạ. Thì em thấy là tại vì em khá thích research về kiểu protocol ấy, giống như những cái như là Ordinal hay là những cái layer 2 trên Ethereum, thì em không biết là cái path như nào thì nó sẽ phù hợp với em ạ. Tại vì hiện tại thì em cứ develop DApp xong rồi develop smart contract thôi, nhưng mà em không thì nó sẽ không có bổ trợ cho cái kiểu cái sở thích nghiên cứu về protocol của em ấy ạ.
So he's interested in developing a Web3 career as a researcher, more like protocol researcher kind of role. And he's asking like where would be the good start for him, because like he has been like doing a lot of DApp development himself, but he feels like it's not there yet. So maybe this is something for you to answer. Okay.
Yes. So the Ethereum Foundation, for people that want to be protocol researcher, has a very good program that is the Ethereum Protocol Fellowship that actually I did before getting my job at the Ethereum Foundation. I did that grant. So I think it's a 4-month grant that allows you to work full-time on Ethereum protocol on different clients.
Có cái chương trình Ethereum Foundation Fellowship dành cho researcher và Ethereum Protocol Foundation Fellowship. Application open form chuẩn bị mở vào tháng 4 này luôn. Nên là em chú ý apply mấy cái này. Nếu mà em được vào cái fellowship program này, gần như là career của em đã set rồi, không cần phải lo lắng về sau nữa. Chỉ cần phải làm sao mà cố gắng pick up được tất cả mọi thứ mà mọi người truyền dạy cho thôi. Yeah. Thực ra ở đây cũng có anh Nam là cũng là một researcher khá là well-versed, khá là tốt, và cũng là người Việt. Anh Nam trước cũng có làm cho Kyber công ty của mình, và sau đây là tham gia vào cái core research của Ethereum PSC, Privacy and Security. Okay, sorry.
Xin chào mọi người, thì mình tự giới thiệu, mình tên là Nam ha, thì hiện tại đang làm nghiên cứu cho Ethereum Foundation. Thì tức là mình cũng muốn chia sẻ một số điều, tức là đầu tiên là cái câu hỏi của các bạn mà về nhúng nhúng á, lập trình nhúng á, thì nó là một câu hỏi rất là hay. Thì thông thường khi mà mình nhìn vào blockchain, đúng không, thì mình sẽ nghĩ đó là cái này nó phải chạy trên một cái máy tính, nhưng mà thật ra điều đó là không đúng. Bởi vì bất kỳ một cái hệ nào đó mà có thể xử lý được những cái tác vụ mà liên quan đến logic á, thì đều có thể chạy được một cái blockchain. Thì ví dụ như trên cái điện thoại của mình, hoặc là trên một cái bộ vi xử lý nhỏ hơn, hoặc là trên một cái bộ vi điều khiển, thì hiện tại là những cái nghiên cứu về blockchain hay là những cái ứng dụng về blockchain đó, nó cũng mở rộng hơn, tức là không phải là những cái mà nó chỉ chạy trên server, chạy một cái máy tính như thế này nữa, mà người ta cũng bắt đầu quan tâm nhiều đến ứng dụng điện thoại hay là những cái bộ mạch mà nó có khả năng xử lý với lại bộ nhớ nhỏ hơn rồi. Cho nên là lập trình nhúng hoàn toàn là rất là có cái tương lai đó, tức là kiểu như là mình gọi là nó là một cái hướng mà mở rộng trong tương lai của mình. Thì cái đó là cái mà liên quan tới cái môi trường của mình. Còn cái thứ hai á là mình khi mà mình làm về những cái mà liên quan nhiều tới phần cứng như vậy á, thì mình có thể nghiên cứu về cái hướng là chuyên biệt hóa một cái phần cứng trong một cái tác vụ nào đó rất là tốn kém ở trong blockchain. Ví dụ như là hiện tại đang có những cái nghiên cứu về zero knowledge proof, thì cái bạn Leo này thật ra bạn đang nói về cái vấn đề là mình sẽ làm một cái phần cứng mà làm sao để mà tăng tốc tính toán là chỉ chuyên biệt cho những cái tác vụ đó thôi, chứ không phải là gọi là chung chung một cái general purpose machine như là computer, mà mình có thể làm hẳn một cái thiết bị phần cứng đặc biệt chỉ dùng cho cái đó thôi. Thì cái đó nó cũng là một cái hướng nghiên cứu rất là hay. Còn cái câu thứ hai về cái Web3 career á, thì đó là ngoài cái chương trình Ethereum Protocol Fellowship thì những cái nền tảng blockchain khác cũng có những cái chương trình giáo dục tương tự. Ngoài ra thì trong những cái ngành hẹp hơn của blockchain, ví dụ như là mật mã hay là gì đó, thì mình cũng thấy rất là dễ dàng tìm kiếm được những cái group mà cùng nghiên cứu, cùng thảo luận online như là ZKP hay là như thế nào đó. Thì các bạn có thể tham khảo thông tin trên internet, chỉ cần mình nhập vào cái từ khóa ví dụ như là study group blockchain hay gì đó thì mình sẽ tìm được rất là nhiều những cái tham khảo như vậy. Tức là không có cần phải lo lắng về cái vấn đề là mình thiếu tài liệu học, mà chỉ là mình không có đủ thời gian hoặc là mình không có đủ nghị lực, hay là nó không có gọi là phù hợp với lại cái hướng phát triển của mình thôi. Xin cảm ơn các bạn.
Ok, còn câu nào nữa không? Các bạn nào còn những ngành khác cứ hỏi thoải mái nhé. Can you pass him the mic? Yeah.
Em thưa anh, là trên hiện tại thì em đang học về data science và định hướng tương lai của em sẽ là làm về tài chính và chứng khoán. Thì em cũng nhận thấy là Web 3 và blockchain là một trong những cái công nghệ mới và thực sự là nó sẽ có những thay đổi lớn trong tương lai. Thì không biết là impact của Web 3 và blockchain nó sẽ như thế nào khi mà mình áp vào cái thị trường chứng khoán và những cái giao dịch mang tính truyền thống hơn ạ? Và mình nên làm thế nào để có thể đón đầu được xu thế?
Wow. So he's like data science and stuff, and he's been like trying to work in like stock market and things like that, and he's trying to understand the impact of blockchain and Web3 in the other markets. I guess it's more like how we can apply all the knowledge or the know-how. Yeah. Yeah. Let me do one take first, right? Thực ra có một cái hay của Web3 đặc biệt là những cái public blockchain như là Ethereum và những cái layer 2 của Ethereum đấy là tất cả data nó available, nó gần như là data nó ở trên blockchain hết. Em có thể là query và fetch đủ các loại data, và nó sẽ không kiểu như là ở trong những private server hay là trong những cái silo environment như ở trong thị trường truyền thống. Thế nên là có một cái hay là em có thể lấy data rất là nhiều và có thể xử lý rất nhiều thứ với cái data đó. Thì anh nghĩ là tất cả những cái know-how hay là những cái algorithms mà mình đang có ở trong những cái thị trường truyền thống hoàn toàn có thể apply được sang những cái open market như thế này. Và nó có một cái hay nữa là với cái data đấy em hoàn toàn có thể là participate được hay là làm được bất cứ những cái algorithm và những cái gọi là strategy riêng của mình. Bởi vì sao? Bởi vì nó permissionless. Nghĩa là sao? Em không cần phải đăng ký account, không cần phải là làm đủ các thứ như ở trong những cái thị trường tài chính truyền thống. Chẳng hạn như là ở DeFi các thứ thì em chỉ cần một cái Ethereum address và em có thể tham gia vào tất cả những cái DeFi protocols. Em có thể làm borrowing, lending là đủ thứ cả. Thì đấy là một cái hay của một cái public blockchain như là Ethereum và những cái Ethereum layer 2. Yeah. Không biết là như thế có trả lời được cho cái câu hỏi của em chưa, hay là I think I want to ask like whether we can use any like blockchain technology for all the traditional like financial data system, right?
I think the traditional financial system, like like I think. I think personally the traditional financial system is like, okay, how do I put this? Like email versus physical mail. Like, how many people here send physical mail? Like, go write a letter and then send a physical mail? Like, no one does this. People use email. I think the traditional financial infrastructure will be just like physical mail in comparison to DeFi and the stuff we're working on now. Like, this is the future of finance, what we're working on here. And yeah, I think the traditional financial system is going to be old, like legacy finance or old finance. And yeah, I think probably what we'll end up seeing is some mixture of traditional finance and crypto and blockchain. So yeah, I think it's much more interesting to be on the side of innovation and know about this, because it will become relevant in the future. Many big banks, big corporations will use this technology. I don't know. Do you agree?
Yep. Yeah, I mean, like, I think a lot of things that anh nghĩ là cái thị trường hay là những cái hệ thống tài chính hiện nay ấy, sẽ có học được rất nhiều thứ từ những cái innovation đến từ blockchain. Đó, chẳng hạn như là làm sao mà cho tất cả những cái protocols, tất cả những cái hệ thống nó có thể là liên hệ, nó có thể nói chuyện với nhau một cách là thoải mái và tự do, không cần phải là permission, không cần phải API key rồi các thứ như hiện nay. Thì làm sao để cho nó tất cả mọi thứ nó chảy một cách gọi là xuyên suốt giữa những hệ thống và những cái ứng dụng khác nhau ấy. Những cái mà anh đang chưa thấy mà tồn tại ở những cái ứng dụng tài chính truyền thống. Đấy, chẳng hạn như làm sao mà những cái ngân hàng hay những cái công ty chứng khoán họ có thể open cái API một cách dễ dàng cho tất cả mọi người để có thể là làm tất cả những cái innovation khác nhau on top of những cái hệ thống sẵn có của người ta. Thì anh nghĩ đấy là những cái mà có thể là về sau. Thực ra là anh thấy hệ thống ngân hàng có vẻ như họ đang cố gắng innovate cái đấy rồi, nhưng mà nó sẽ tốn rất nhiều thời gian hơn so với một cái môi trường mở, và nó đã xây dựng với một cái philosophy là tất cả mọi thứ sẽ mở và permissionless ngay từ đầu.
Em thì không có câu hỏi, nhưng mà em tính bổ sung thêm một cái ví dụ về cái việc mà blockchain có thể thay đổi cái tài chính truyền thống hay là không. Thì em xuất phát điểm là một bạn học về ngoại ngữ marketing và không có liên quan gì tới công nghệ thông tin. Và khi mà em được biết đến blockchain và học ý, thì cái mà khiến em thích nhất đấy là cái khoảng thời gian chuyển tiền ấy ạ. Thì ngày trước là em có cơ hội làm việc với nước ngoài, và mỗi lần mà công ty em phải chuyển tiền từ nước này qua nước kia thì nó sẽ mất từ 4 tới 5 ngày làm việc. Trong khi nếu mà sử dụng blockchain để chuyển tiền thì nó chỉ mất khoảng vài giây và không cần phải quá là nhiều giấy tờ ạ. Thì em nghĩ là đó là một cái mà có rất là nhiều ngành sẽ cần, giống như kiểu là logistics. Em xin hết.
Đấy, mọi người thấy không? Chị này là cũng không phải dân technical, không phải dân kiểu IT hay là embedded system gì cả, nhưng mà vẫn có thể là vào cái một cái Web3 economy nó khá là năng động và sôi động như này. Okay, there's yeah.
Okay, last question. Who raised the hand? Okay.
Em nãy anh có nghe nói là hiểu về mạng Ethereum ấy, thì em có một câu hỏi là khi mà bắt đầu tìm hiểu về một mạng lưới ví dụ như Ethereum chẳng hạn, thì mình có những cái khía cạnh nào cần phải chú ý không ạ? Như hiện tại thì không biết là nó cần có những cái khía cạnh giống như bên web 2, như hiện tại làm web 2 thì có những thứ chú ý, như ví dụ như về server thì có những cái tính như là bảo mật, tính sẵn sàng cao, các tính sẵn sàng cao, và một vài cái như là có thể scale được. Còn không biết là đối với những mạng lưới trên blockchain giống như Ethereum thì khi bọn em bắt đầu tìm hiểu research về nó thì có những khía cạnh nào hay có những hướng đi nào mà có thể giúp bọn em tìm hiểu một cách có thể thuận tiện hơn được không ạ? Thì mong anh chia sẻ giúp em. Cảm ơn.
You want to take this? So the question is, what are the things or the concerns that a new developer should be aware of when they start with like Ethereum development? to Web 2, yeah. So Web 2, like, they need to know about the server scaling, all the security flaws and things like that. Yeah.
So I would say web things you learn in Web 2 development still apply in Web 3 development. They are still very relevant. So if you're learning about like high availability, security, all of these things are still also relevant in Web 3. Web 3 is built on top of Web 2. Web 3 uses a lot of Web 2 technologies. In addition to things that you would normally think about or learn for Web 2, there are some extra things you will want to learn. Things like decentralization, or like how censorship resistant is your project, or how accessible is your project worldwide, how neutral is the blockchain on which you are building. So there are some things that are different in Web 3 that you need to think about. But most things you learn in Web 2 still do apply in Web 3.
Yeah. Không biết là bạn đã hiểu cái câu trả lời của anh ấy chưa? Nói chung là mình nghĩ là những cái gọi là philosophy, là những cái best practices trong Web 2 ấy, nó vẫn sẽ apply sang Web 3 thôi. Đó, chẳng hạn như là làm sao mà program nó không bị bug này, làm sao mà cái permission control của mình nó đủ tốt. Chẳng hạn ai có thể là submit vào cái function này, ai có thể gọi được vào cái function kia chẳng hạn. Hay ngay cả cái chuyện scaling cũng thế thôi. Làm sao để viết cái chương trình mà nó tối ưu được cái chi phí, cái gas cost của users, hay là làm sao mình có thể là serve được nhiều users hơn mà cái chi phí nó vẫn tiết kiệm được. Tất cả những cái đấy là như là những cái concern nó vẫn là như nhau thôi, chẳng qua là trong một cái bối cảnh khác, một cái environment khác thì mình sẽ phải sử dụng những cái kỹ thuật nó khác đi một chút thôi, chứ còn bản chất là nó cũng không khác gì nhiều lắm. Okay.
Lloyd, thank you so much. Big round of applause. That was amazing. Yeah, it was great to have him. Improvisation, but yeah, amazing to have you speaking here directly to, yeah. Oh yeah, we have one more talk in Vietnamese, exactly. Thanks for the mention. Yeah, right after this talk. But first, yeah, welcome back to Kevin. That will talk a little bit about data indexing. Yeah, up to you.
Hello again. It's great to see you guys. You guys look amazing. Okay, as I have probably already told you, my name is Kevin Jones. I am a developer relations engineer. So what does that mean exactly? Well, I work with developers that are building on Web3, and I help them, learn how to build, learn how to create solutions that make sense. And more importantly, at the Graph, I deal a lot with data, right? Helping people organize their blockchain data and make it easily consumable in their applications. So that's what I'm going to talk about today. So I think we've kind of talked a lot about the DApp architecture. So we have this concept of a decentralized application, right? You have a front-end application that is HTML, CSS, JavaScript, all the static assets, right? And this is kind of the initial design as you deploy that static application. And then you have your business logic or your smart contract that lives on the blockchain, right? And this is great, but when it comes to reading data from the blockchain, reading data from Ethereum is free, right? You can do a JSON RPC to get the current value of a variable, right? You pay for security, the state of the variable, right? To update that variable. Or to update anything in the smart contract. But for reading, it's free. So the nodes are not really incentivized to serve, I guess, quick and reliable amounts of data. And so there is this issue where it is a little bit slow and it's cumbersome, like the JSON RPC is not really optimized for reading data. Actually, the JSON RPC endpoint was originally created to manage an Ethereum node and not really to query. So what we see is something like this in the wild. This is actually real code at a hackathon where someone wanted to get all of the NFTs in a particular wallet. So all they needed to know is how many NFTs did this user have when they connected their wallet. So you have to do this thing where you create an object, you get the balance of the actual wallet, then you have to loop through that balance and get all of the token IDs and then push those into an object and then display those as a result, right? Using the return. And this is okay if you only have like 2 or 3 NFTs, but if you have hundreds of NFTs or thousands of NFTs, which believe me, there are people like that, this could easily take minutes to load a web page because it's having to go through and build this object. And every time it does that, it's doing a call, an ETH call, a JSON call, JSON RPC call. And so this is just unreliable, right? So what we actually want to do is index the data, right? We need to find a way that we can index the data and make it highly available. And so the general method to do that is called the ETL queue, right? So you take the data, and this applies to all data, I guess, data science and data analytics, is you want to extract the data. You probably want to transform the data in a way that makes sense for you to actually consume it later. Load it into some kind of database or some kind of object, and then make it queryable so it's easily accessible, right? So if we think about an Ethereum block, like every single 10 seconds, there's a block. Inside of that, there's hundreds of transactions. There's people are sending ETH across from each other. People are calling functions. They're updating state, whatever. There's a lot going on, and there's a lot of different protocols that are emitting these events, right? We talked about events earlier. We created a few and emitted those, and you know what those look like. So it's a kind of a mess. It's kind of a sea of craziness. So what we want to do is take those events. So a smart contract emits an events, and then we want to store those somewhere, right? In some kind of database or some kind of consumable way. So what is the graph? Well, the graph is a solution, or one of the solutions to this problem. It is essentially the data layer of Web3. So we are a decentralized network of nodes. So similar to how Ethereum has a decentralized ethos to it, so does the graph. All of these nodes are running indexers. They're called indexers. And this is what you actually see live in footage of what it looks like. So I don't know how this works, but if anyone can tell me, that would be great. I feel like this is somehow rigged, but anyways, this is what the graph does, is it organizes all those crazy mess of transactions into buckets that we call subgraphs, okay? So we take that initial architecture where we have the app that sits on the front, the front end. We have the blockchain, the smart contract. It's still incentivized for the security of the network, but we implement this middle layer, right? This middleware layer, and that is called the graph, right? So what we can do, I don't know what's up with the load time on this, but there we go. The graph is built, and I'm going to dive into this a little deeper, but it uses what's called GraphQL. Show of hands, who here has used GraphQL? A few of you, okay. So it makes sense to talk about it then. The cool thing about GraphQL is it is called a query language, graph query language. So it allows you to do a query, pass in variables or data that you want, and then get exactly the structure that you want. So like if you wanted to eliminate the token ID or the metadata or whatever it is, you can customize the query, and that will optimize the data response that you get back, right? So this is very, very useful for front-end developers particularly, because you can do a GraphQL query against your data, and with that same kind of code I showed earlier, we can just do one single HTTP query against the GraphQL endpoint to get all of the data we care about. So no looping, no building objects, just a single query. So again, we have the network participants. This number changes, but you can say there's at least 200 indexers running on the network that are indexing data. And there's also people that are just involved in the protocol, maybe even some of you guys that have staked some GRT. You can do staking, like similar you can with Ethereum. You can also curate subgraphs. So if there's DeFi protocols that you think are very popular, you can go on there and find those things and then add some stake there. You can also deploy your own subgraph if you're a developer, and you can get paid for the queries fees that go through that. So there's a lot of ways you can interact with the graph. And so in the end, I think the goal is to build truly decentralized apps. And in order to do the data in a truly decentralized way, you need something like the graph, which is a decentralized network. So here we have the same ETL queue that I talked about. So in this case, Ethereum, all of the events are available over JSON RPC. So we extract them using just a standard JSON RPC call. We transform those using a processing engine called a WASM. WASM is basically a WebAssembly. And we use assembly script, which is very similar to TypeScript. So if you've kind of used TypeScript before, assembly script is very different. It's a little bit, it looks exactly the same, but it has a little bit less features than TypeScript. And you can process the data or transform it however you want. And then you load it into a database. So the graph is built on Postgres. So we have all of the indexers run Postgres, and that's where they store all of the data for the subgraph. And then that's exposed using GraphQL, right? And the beautiful thing about this implementation is it is open source. We use Postgres, which is open source. We have GraphNode, which is all open source. And we use IPFS, which is the interplanetary file system, which we didn't really talk about that today, but it also is a very important part of decentralization. But we use all of those three things, so it's a completely open source and anyone can be involved. You can even run your own indexer. You don't even have to be a part of the network. You can just run it yourself. So this is kind of what it looks like at a high level. So imagine you have your DApp, right? HTML, CSS, JavaScript. You still deploy your smart contract on the Ethereum chain of your choice. You still propose transactions and make transactions to your smart contract. But in this case, your smart contract emits those events. Those events are picked up by what's called GraphNode, which is the open source engine that essentially does the processing of the data. You can think of it as kind of like similar to the EVM, but it runs a Rust program that is isolated and protected. So it runs that data. It does what's called mappings inside the WebAssembly. And it stores those in Postgres. And then it provides a GraphQL API for your data. So that same sea of mess that you see gets kind of consolidated into something like this, where have these unique buckets that you can actually go to and then get the data you care about. So if you care about, you're into DeFi, you want to look at Uniswap, which is our most used subgraph, you can go on there and see all of the swaps that happen. You can see the TVL. There's all sorts of calculations that are in there. We have Aave. If you're into NFTs, we have Foundation, MakerDAO, Zora, whatever it is. You can search on the Graph website. So if you go to thegraph.com/explorer, any kind of Web3 protocols available on there. And if there's not one, you can build one, and then you can get incentivized to store that data or to do that. This is very useful if you guys are at all interested in what we did today, and you guys were very interested in the speedrun challenge. I also did a full stack workshop. We have a special branch of Scaffold ETH that comes with the graph integration. It's called the subgraph package. And this URL will take you, if you just go to bit.ly/fullstackdapp, or if you scan this, it will take you to the GitHub. And then inside the GitHub, there's a video. So you can watch the video. It's about an hour and a half long. I go through the workshop and teach you about scaffold ETH, and I teach you about the graph and all that stuff that I just talked about in much more detail. I think I just want to show really quickly the graph website. So if you go to thegraph.com and you kind of take a look, when you first go there, there's a few different things you can do. If you're a developer and you want to create customized subgraphs, you can go to the Subgraph Studio. If you are a developer and you just want to get access to existing data that's already available, right, then you go to the Explorer. So as an example would be, let's say you wanted to know about, who here, raise your hand if you've heard of CryptoPunks. CryptoPunks, no? Little guys with mohawks and glasses. No one's seen those? Overpriced JPEGs. So if you, let's just give you an example. Let's say you did a CryptoPunks, do a search. You can find all the subgraphs for CryptoPunks that are available. So if I want to grab this one, I can click it. Those are CryptoPunks, by the way. And you can come and see that this data is indexing. It's 100%. And we can see who's indexing it. These are all the indexers on the network that have indexed it. These are all decentralized indexers. And you can also see who's curating on it. But more importantly, you have this playground. And here you can say, okay, well, what do I care about? Well, let's say I want to get all of the punks, their ADs, who owns them, etc. I can just hit play, and it gives me all the data back in this easy to consume GraphQL API. So this is really cool because you can just plug this in to Python. You can plug it into whatever, whatever programming language you want. You can do a query. There's a lot of GraphQL SDKs and ways that you can interact with that. There's also some Python tooling, JavaScript, you name it. There's tons of ways to get that data, and you can make a query, get that data back, and do whatever you want with it, right? So whether it's building a front end for some kind of DeFi protocol, or maybe it's you want to do some AI stuff, maybe you want to do some machine learning on it, you can get that data, and it's available. Okay, so yeah, if you guys want to get started, the best way to do that is to go to the docs. So anyone who wants to learn more about the graph, go to the docs, and there is a section called the Quick Start, which is, there's some stuff about the graph, how it works, but I think right here, the Quick Start, especially if you're a developer, is kind of the best starting point. So you click that, and it will kind of walk you through. But if you just want to, in general, learn about the graph, there's tons of resources here in the docs. It's not loading right now, but if you go to thegraph.com, everything you need is there. Yeah, I'll give 5 minutes for questions. Does anyone have questions at all? No questions? 1, 2, 3. Oh, I see a hand up there. All right. Yes. Yes. I always pull at least one question out of the crowd.
Yeah. So, what is the difference between the graph and traditional block explorers? Yeah.
Great question. So the difference between the graph and traditional block explorers. So traditional block explorers usually have centralized infrastructure. None of them actually, that I know of, use the graph. Maybe some of them do, but for the most part, they're probably storing data in their own centralized solutions. So I would say they're a little bit less trustworthy in that sense. Whereas something like the graph is, we have, let's just say for this example I just showed was a CryptoPunks, and there's 15 indexers. You can kind of guarantee that the data that is on those indexers is probably 100% correct, because if one of those indexers operates in a malicious way, they'll get their stake slashed. So is in the best interest of serving accurate data. Whereas something like a block explorer could easily be hacked to manipulate the price, let's say, of a token, and show that a token maybe is worth more. And if someone is using that as a source of the price, that could be a security problem. So that's the main difference, is you're using a decentralized network which has a consensus and proof of whatever you want to call it, proof of data, versus something that's centralized that you don't really have a way to verify. Yeah. Hope that helps.
Yeah. Okay. Good. Thanks.
Yeah, good question.
Yeah.
Any other questions? Awesome. You guys are amazing. Thank you so much. Love you guys.
Thank you so much, Kevin, for all your talks today and workshop. You've been amazing. Thank you so much.
FOSS hat trick.
Up now, we have Leo, protocol research engineer at the Ethereum Foundation. He's coming in a bit, but he will talk about zero knowledge proofs, and we'll do a little workshop on that as well.
Thank you, FOSSASIA and all the people here in Vietnam organizing this amazing event and expanding open source and free software around the world. Now, I've been in free software open source like for more than 2 years, and it's an amazing community and a great purpose. So now I'm going to talk about zero knowledge proofs more from a perspective that is good for like a student of computer science or software engineering. That is like zero knowledge proofs are more kind of commonly talked in the sector of more like cryptography, and the base is cryptography, but has like a software engineering, no? Has a lot of software engineering applications, no? And is starting to get to the general domain of software engineering. We are getting there, although currently most people working in zero knowledge proof are cryptographers. I, as a software engineer, really, that got into this stopped working, or perhaps you need to click on it. Oh. What? Yeah, it was not in the focus of the window. Yeah, no, it's all. Yeah, okay. Because it moved. Okay. So yes, yeah, it's working. Yeah, it's working. No, yeah. Yeah, because so I started working in the PSC, that is kind of like the Department of Ethereum Foundation that works on zero knowledge. No, I have more like a background in software engineering and kind of like work my way into zero knowledge proof. And I think really zero knowledge proof is already ready for normal software engineering and for like computer science students in the software engineering students to learn it and start kind of building applications with it. And that's kind of like the focus of my presentation about how to understand it from this perspective of the software engineering. It's again, yeah, they lose the focus. Okay. So what is zero knowledge proof? No, for if we want to explain it not from like kind of the cryptography that is based on, but like from a point of view of what you can do with it, no? So it's a system that allows you to prove that you know something without giving all the information about it. And so you can also see it if you are applying it to software engineering, no, as a way of proving that I have done a computation. I can prove that I have done a computation from an input to an output without revealing all the information. I can reveal part of the input or not the input or the output or the intermediate values in this computation. No? So that's kind of like what is zero knowledge proof as applied to software engineering. So there is like some examples. I put here some links, so some example to kind of like try to intuitively kind of understand what is a zero knowledge proof. I will share the slide later, yeah. And this is like kind of like very typical example, okay? So in this case, like Alice is colorblind, okay? And Bob wants to prove to Alice that he can distinguish two balls of that is pink and well, red and blue. So Alice is colorblind and Bob is going to prove to Alice that he can distinguish the color. So what we do is like Alice kind of like puts the balls, takes the balls and puts them in behind her back, and she chooses whether to swap them or not, and then show them back to Bob, and Bob tell her whether she had swapped them or not. And if we repeat this many times, and Bob is always right, at some point probabilistically, Alice is sure that both can see the different colors of the balls, but Bob has not revealed to her what is the color of each ball. So there is like this, like privacy, like hiding information, like Bob doesn't have to explain to her which ball is each color. And anyway, Alice gets convinced after repeating this enough time, probabilistically, that the probability that Bob doesn't know which ball is really close to zero. No, there is another example here. I have, for example, here, like you can do, the game like Where is Waldo? Do you know this game? You have like this image, like with a lot of things going on, and there is this character is somewhere here, and the game is to find it. And another example of zero knowledge proof is you can prove that you have found Waldo without telling the other person that you are proving to that, so without telling you what is Waldo. So in this example, you can just like get like a very big piece of paper that is bigger than the Waldo story, and you do a cutout of Waldo, and you put it in front of the paper, and you show Waldo through the cutout. That way, you are proving that you have found Waldo, but because the paper is much bigger than the comic, that way you don't have to, like, the person is not revealing where is Waldo. It's just revealing that knows where is Waldo. So this is the concept of zero knowledge proof, like kind of explained with this physical example. Any questions about this? Everybody understand this? Okay, let's continue. So what is this used for? What is this useful? No, one of the main purposes, the main things that you can use this in software is for privacy. So you can compute things and you don't have to reveal all the information. No? So for example, in blockchain, you can use for privacy in blockchain transactions. Or for example, there is an application that PSC is working like with the digital ID of India and on Hadar. So you can, for example, generate a proof that you have certain age without revealing the rest of the information of your ID. Then there is scalability. If the computation, if I'm proving that I have computed, like normally, if I tell you, okay, the result of this computation is this. For you to be sure that I'm telling you the truth, you have to compute it again and see if you get the same result. With zero knowledge proof, I can give you a proof that I have computed this and that is the actual result. And probably verifying the zero knowledge proof, it takes less space, like less memory and less computation than the computation I'm proving. So that gives us like the power of scalability. No, that's what like the CK rollups use it for example. And then it can be used also for interoperability. I can prove you facts about a public blockchain, for example, and you can believe me and communicate between systems and between blockchains. Yeah. Then we have like, this is the concept of zero knowledge proofs. And now the kind of like the innovation that is kind of making this kind of being usable in software engineering and for creating applications is the invention of the general proving systems. No? So we have systems that allows you for a general computation to create a zero knowledge proof. Before this, you have to kind of work out for each problem how you can create a zero knowledge proof. No? For example, with a proving system, using a proving system, I can create a proof of bubble sort. So I can create a protocol with this proving system that you can give me an array and I can prove you that I have sorted it with bubble sort. Perhaps sometimes without revealing if I don't want the sorted array or the intermediate values, or for example, for a Sudoku, I can create, like using the proving system, as a protocol that you give me a Sudoku unsolved, and I can prove to you that I have found the solution of the Sudoku without revealing you all the numbers in the Sudoku. So that's kind of like, everybody understand at this point? Because this is kind of, the idea is to kind of generate more like kind of questions so we can explain the things better. Yeah, okay. Okay. So, so the main misconception, like people, if you already heard about zero knowledge proofs from you are studying software, or you are a Web 2 developer, kind of like there is these ideas that you need to do, like you need to know a lot of advanced math to be able to do zero knowledge proofs and to build zero knowledge proofs applications. And I don't think that's true. Now we have more languages on top of proving systems that are kind of helping you immensely. So you don't need really to know the underlying math that zero knowledge proofs are based on. You need this advancement to create the proof systems, but you don't need, in the same way, like someone can learn Python without really knowing how microprocessors work with this proving system. You need to do this known math to create the proving system that is like the CPU, but you have these kind of things closer to Python, although not that far. That are the proving systems and the languages that allows you to create this zero knowledge proof most easily. The very popular known language is CIRCOM that make it easier to create zero knowledge proof, and we are working in Chiquito at PSC, and there are many other languages that make it more easily to build zero knowledge proofs. There is it's still an obscure sector, like where more people work from cryptography. So everything is explained in cryptography terms yet, and there is not so much kind of education material for software engineers. So a good source, I think, is ZeroXPark. Have a very good couple of tutorials in CIRCOM and Halo2 that are very good. Okay. So what is, like, when you are building your zero knowledge proof protocol using a proving system, what are, as a software engineer, what are the things you have to consider, okay? So the first thing is the witness. What we call the witness is kind of all the data about all the data that you are creating the proof about. So the witness, usually if you are thinking, we're creating a proof of a computation of algorithm, the witness includes the input, the output, but also all the intermediate values that we're doing in the computation. And like talking about the zero part of zero knowledge, like some part of the witness is private. So sometimes, like, we call advice to the private part and instance to the private part. But the whole witness in proving system, usually you arbitrarily can choose kind of like what part of the witness is public and what is private. So what only the one generating the proof will know. Then there is like kind of like the setup or the circuit or the arithmetization. We can call it by a different name, but it's kind of like basically from a higher level point of view, from an application building point of view, is a series of like constraints of assertions on the witness. So we are saying, okay, only the witness that follows this arithmetization, this setup, this circuit are valid. Actually, we are proving that we have done this computation only if this setup matches this witness and is true for this witness. Okay, and then there is the witness generation. That is kind of actually the algorithm itself that we are proving, that is generating all the witness values. That's like different things you need to consider as a software engineer. Then there is the proving and the validation key. So for the circuit, for the setup, we get two keys that are both publics, and the prover having a witness using the proving key can generate a proof, no? And this, but they can generate only a valid proof is if the witness is kind of matches the constraints that we have put in the setup. Okay, this is kind of clear until now, yeah? Yeah, you all know it already? Okay. So the validator is like can get a proof and just with the public part of the witness and just with the validation key can check if the proof is valid. So the validator will be sure that the prover has a witness that matches the setup. And that also this witness, like the public part, is this public part, okay? So I try to explain it here in a very cool diagram, okay? Okay, so let's see if everyone kind of understand. So we are trying to generate a public, a zero knowledge proof protocol for a specific algorithm, okay? So what is the developer? The developer kind of like have to build two things, two programs, okay? Need like the normal, doing normal programming have to build the witness generation, okay? And like in what is called like the arithmetization, the setup, the circuit, is going to specify kind of which witnesses are valid, which witnesses are always the result of the algorithm we want to compute. No? The witness contains all the information, including intermediate values, input, output. No? So this arithmetization defines what is valid. No? So for example, for a Sudoku, the delimitation defines what Sudokus are valid Sudokus. No? Okay? And the witness will build the intermediate values to calculate the Sudoku itself and not the intermediate values to calculate the Sudoku. No? And then from this circuit, the setup of the proving system will generate a proving key and a verifying key. Okay? And then this is like the star are kind of executed for different inputs, are executed many times, no? Like for each input. So in the case of the Sudoku, let's follow with this case, no? Like the input would be kind of like the unsolved Sudoku. The witness generation would generate like kind of like a solved Sudoku, okay? And then the prover with the solved Sudoku, the proving key can generate a proof, with the public part being the unsolved Sudoku, and the verifier, there is another person, with the verifier can take this proof and be certain that this prover has solved the Sudoku, without receiving more information that was made public in the protocol. I don't know if like everyone understand this. So we'll kind of like overview from kind of like a programmer point of view of what they have to do to kind of generate a zero knowledge proof protocol. Yeah. No. Okay. Okay. That's very good. So I have some. This is going very fast. This is the time that is going faster. I have like some example code to show you kind of like how is this in Circom, okay? So very, very simple example, no? Like the computation we want to prove is like this equation, no? X to the third minus X plus 7 equal Y, no? So with the proof system, we can for example, prove that we know an X and a Y that matches this equation, and then we can depending on how we define the circuit, we can even not reveal X or Y, or only reveal Y, or only reveal X. No, but like the verifier will be sure that we know a solution. Okay, and this we were talking about witness generation and the kind of the setup part of the circuit part. Like and the witness, no? So let's identify a bit here the different parts, no? Like here these that are called signals in Circom. This is kind of the witness, no? So our witness in this circuit has four components: X, X squared, X cubed, and out. Okay, EX is an input, out is an output. Okay, and the rest of the signal are kind of intermediate values, but all of them together are the witness. Okay, and then we need to do the witness generation that is done with the single arrow in Circom. We basically, this program is executed well. Yeah, this program, when we're evaluating the witness, this program is executed and the arrows kind of like assign values to the signals and hence to the whole witness, because X is given in the input. And these are the constraints. These three equals defines the circuit, like what are the possible values that are valid witness. In this case, they are the same, and in the most simple cases, sometimes they are the same. So that's like there is an operator in Circom, there is like the double arrow that does both things at once. But I think it's clear, like, to kind of like show that there is like two different things. This defines which witnesses are valid, and this is one way of generating the witnesses. No, we need to use x squared and x cubed because, like, in Circom we cannot have like in one constraint. In this arithmetization, we cannot have more like the power of 2, like more than a degree 2 polynomial. No. So that's a constraint of the arithmetization. So that's why we need x squared, x cubed. But this kind of like what I want to explain, no? This kind of defines, okay, like the x squared, x cubed out, there are valid witnesses, have to follow these rules. And this is a way of generating these values that follow this rule, okay? But there can be other ways, and that's okay. So with this program, using with this code on Circom, using Circom, you basically can do this, no? Like the witness generation and the circuit is kind of in Circom is in the same kind of code, no? So the witness generation is the single arrow, and the circuit is the triple equal. And from that, no, you can execute all this. From the circuit, you can create the keys, and then you can do this for all the x. You can execute for all the x. You can execute the witness generation. Well, I mean the single arrow. You can execute for any x. In this case, will be x the input. This generate all the values, the 4 values on the witness. And then the prover could generate proofs that include the part we want to make public, for example, x. No, so we would prove that we know a y that given an x follow the equation, and and then the verifier can be sure that the prover knows the solution of the equations without having to compute the whole equation. So we can imagine, like, if this, instead of this example, we have like a very complicated, very, very, very hard computation to do, because we can do this like much easier. This can help with scalability, no? Because I can give you a proof that I have that the final result of this very complicated computation is this one, and you can be certain without having to calculate it again and seeing if I'm telling the truth. And this is one of the ways that is used mostly in blockchain for rollups and L2s and all that. And that's kind of like completed. Thank you very much. And if you have any questions, let me know.
In the Circom language, right, there are 2 steps I have to do. I have the witness generation and I have this circuit arithmetization. Yeah. If these 2 statements don't match up, does the compiler like verify that and tell me, or does this blow up in my face at runtime?
No, like if you mean if wait, did you go? Okay. You mean if you present a witness that doesn't match the triple equal equations?
Yeah, for example, if, like, I say out is cubed minus x plus 7, right? And below that I say cube out is equal to max.
Yeah.
The second one, in a second, so up there I say out is cubed minus x plus 7, and down there I say plus 6.
Yes. Yes.
What happens?
So you can, so only if you present a witness that follows these equations, you will get a valid proof. So if you change the equations, you will need to present a witness that follows these new equations.
Okay, so me as a programmer, if I make a mistake there, the result will be that the prover will only generate...
The prover will generate an invalid proof. If you present a witness that doesn't follow the equations, the prover will generate an invalid proof.
Okay.
So the verifier will know if it's valid or not. Yeah. If your witness, the verifier will know if your witness matches your circuit because the proof is valid or not.
Okay, okay.
Good. Okay.
Any other question? I have one actually.
Okay.
Do you have examples of zero knowledge use cases or applications that are live today?
Alive?
They're alive, yes.
Yes, like, well, all the Polygon Hermes, Scroll, all the CK rollups, CK Sync. Yeah, that's the one that I'm more familiar with. No, we have Tornado Cash.
So Tornado Cache is for privacy and
yes,
ZK rollups for
scalability. Yeah, yeah. So that, yeah.
Interesting. Thank you. All good. Well, thank you so much, Leo. That was great.
Thank you.
Thank you so much. Thanks again. And last but not least, we have Nam, researcher at the foundation as well in the PSE team, Privacy and Scaling Exploration team at the Ethereum Foundation. And the talk will be in Vietnamese. So thanks again for staying with us until the end. That's going to be a great talk. We just need to set up and we'll be ready in a minute.
Xin chào tất cả mọi người ha. Thì hôm nay mình sẽ giới thiệu một cái công cụ mà lập trình tên là MPC cho mọi người. Thì đây là một cái công cụ rất là hay. Thì nó cụ thể làm cái gì thì mình coi như thế này ha. Đầu tiên là mình sẽ đưa ra một cái bối cảnh mà mình có thể sử dụng MPC. Nó là một cái bối cảnh rất là đơn giản. Thì Elify nghĩa là gì? Là explain like it is fine, nghĩa là cho một cái đứa nhỏ mà 5 tuổi vẫn có thể hiểu được. Thì mình có thể nhìn vô cái ví dụ này. Thì giả sử như là mình có hai đứa nhỏ, một đứa tên là Alice, một đứa tên là Bob. Hai đứa này là bạn với nhau đúng không? Thì tụi nó có một cái cuộc thi rất là con như sau, là sau cái Tết Nguyên Đán á, thì là tụi nó sẽ có những cái lì xì này như thế này. Thì cái câu hỏi tụi nó đặt ra cho nhau là khi mà gặp nhau là ai được nhận được nhiều lì xì hơn, đúng không? Thì đây là một cái tình huống mà tụi nó sẽ muốn biết là ai có nhiều tiền hơn, nhưng mà tụi nó không có muốn kiểu gọi là tụi nó sẽ không, Bob sẽ không có muốn Alice biết được là cái Bob có bao nhiêu tiền, và Alice cũng không muốn không muốn cho, đó là tụi nó là hai đứa là không có muốn không có đứa nào mà muốn đứa kia biết là mình có bao nhiêu tiền hết, đúng không? Nhưng mà tụi nó vẫn có nhu cầu là muốn là tìm hiểu về cái vấn đề này là như thế nào. Ok, thì cái bài toán này nó sẽ được giải quyết như thế nào ha? Thì mình có thể tưởng tượng là mình sẽ có một cái lời giải rất là đơn giản cho cái này. Nó là như thế nào? Giả sử như là hai đứa này tụi nó có chung một cái bà dì này là một cái người rất là thật thà, đúng không? Thì rõ ràng á, là khi mà tụi nó nói với lại cái bà dì này á, là ok, dì ơi, Alice sẽ nói cho dì nghe là Alice có bao nhiêu tiền, và Bob sẽ nói cho dì nghe là Bob có bao nhiêu tiền, nhưng mà dì không được nói cho đứa còn lại hết. Và bây giờ cái nhiệm vụ của dì á là thứ nhất là giữ bí mật, thứ hai là tính toán xem là đứa nào có nhiều tiền hơn thì nói cho hai đứa nghe, đúng không? Thì giả sử như lúc này bà dì này, bà sau khi mà bà có đủ thông tin rồi đó, bà sẽ nói là Bob có nhiều tiền hơn, mà không có nói cụ thể là Bob có bao nhiêu và Alice có bao nhiêu. được chưa? Thì đây rõ ràng là một cái lời giải mà hai đứa nhỏ này rất là cần, đúng không? Thì mình nhìn thấy cái bối cảnh này á, nó rất là giống với những cái gì mà đang diễn ra trong cuộc sống hàng ngày của mình, đúng không? Ví dụ như mình làm cái gì mình cũng sẽ thông qua một cái bên trung gian mà mình gọi là tin người ta đi. Ví dụ như là mình chat với nhau thông qua Facebook chẳng hạn, đúng không? Hoặc là gửi email thông qua cái server của Google, được chưa? Thì không có cách nào để mà đảm bảo cho những cái gọi là, đây có một cái giả định đó là cái bà dì này là một người rất là trung thực. Thì mình không có bất kỳ một cái gì mà đảm bảo được là Facebook sẽ trung thực với mình và là Google sẽ trung thực với mình. Thì thực tế mình cũng đã thấy một số cái trường hợp là thật ra họ đang thực hiện một số cái tính toán mà trên cái dữ liệu cá nhân của mình mà mình không có biết được, đúng chưa? Thì lúc này cái giải pháp của mình là khi mà không có một cái bà gì trung thực như vậy, hoặc là khi mà không có một cái bên thứ ba trung thực mà mình có thể tin được á, thì cái giải pháp của mình là cái gì? Đúng không? Mình sẽ dùng cái công cụ tên là MPC. Thì cái MPC này là một công cụ được xây dựng bằng mật mã ha. Thì cái về mặt mà mình là cái ý niệm khi mà mình sử dụng cái MPC công cụ này á, thì là nó hoàn toàn là giống với lại việc mà sử dụng một cái bên thứ ba trung gian mà mình tin tưởng, được chưa? Tức là từ cái khía cạnh mà người sử dụng là hoàn toàn không có gì thay đổi hết, chỉ có thay đổi là cách thức tính toán hay là cách thức truyền tải dữ liệu như thế nào thôi, đúng chưa? Cái này với cái này về cơ bản là mình chỉ thay đổi cái hộp này thôi. Ok. Thì cụ thể MPC là cái gì? Thì MPC là viết tắt của cái từ tên là Secure Multi Party Computation, nghĩa là Multi Party là đa bên, đúng không? Đa bên, computation là tính toán. Thì cái này là một cái hệ những cái giao thức mà hỗ trợ cho việc tính toán đa bên nhưng mà có tính bảo mật ở trong đó. Thì mình có thể tưởng tượng là cái MPC này là một cái hộp đen mà khi mà Alice và Bob đưa những cái gọi là thông tin riêng tư của mình vào, ví dụ như là một cái thông tin là một cái biến XA đi, Bob đưa một cái biến XB đi, thì cái hộp này nó sẽ tính cái hàm F trên XA và XB và trả ra kết quả Y. Và tính chất của cái hộp này khi mình sử dụng á, nó sẽ có 3 cái tính chất quan trọng sau đây. Tính chất thứ nhất là tính riêng tư, nghĩa là khi mà Alice và Bob tương tác với nhau thông qua cái hộp này thì cái biến XA và XB này nó sẽ không có được để lộ cho cái bên kia. Cái tính chất thứ hai á, tính chất quan trọng thứ hai là independence of input, nghĩa là cái tính độc lập của những cái dữ kiện mình đưa vào. Thì mình có thể tưởng tượng là giả sử như bây giờ mình đang deal lương với lại nhà tuyển dụng đi, thì ai đi trước là sẽ bị thiệt thòi, đúng không? Thì lúc mà mình dùng cái hộp này á, thì rõ ràng là cả hai bên sẽ cùng phải đưa cái thông tin vào cùng lúc, và không có bên nào mà có thể thay đổi hay là đưa cái thông tin của mình vào trong cái hộp này mà gọi là phụ thuộc vào cái giá trị mà bên kia đưa vào, được chưa? Thì đây là một cái tính chất rất là hay của cái hộp MPC này. Và cuối cùng một cái tính chất không kém phần quan trọng đó là tính đúng đắn, nghĩa là cái kết quả Y này nó phải tính đúng cái hàm F trên XA và B, chứ không phải là một cái phép tính ngẫu nhiên nào hay là một phép tính nào khác F. Thì để mà giải thích là hồi nãy cái bạn Leo á, bạn đã giải thích về cái công cụ tên là ZKP rồi, đúng không? Thì thật ra cái ZKP với lại MPC này nó có một cái mối quan hệ rất là sâu sắc với nhau, khá là gần gũi. Thì công cụ ZKP là cái gì? Công cụ ZKP á, là nó cho phép mình chứng minh là mình biết được một cái gì đó, được chưa? Thì trong cái bối cảnh mà tính toán á, thì nghĩa là giống như là mình khi mà mình giải một bài toán này, đúng không? Thì mình sẽ có từng cái bước suy luận của mình từ đầu vào tính toán cho đến đầu ra, đúng không? Thì cái ZKP này á, nó sẽ cho phép mình là chứng tỏ là cái sự là mình biết được từng bước nó diễn ra như thế nào, và từng bước đó là một cái diễn giải đúng, được chưa? Thì cái ZKP này khi mà mình ứng dụng vào cái tính toán như vậy á, là bằng cách là mình chứng minh là có sự tồn tại của một cái lời giải, thì có nghĩa là cái phép tính của mình đã được tính đúng, đúng không? Rồi, nhưng mà khi mà mình nhìn cái ZKP này nó tổng quát hơn á, thì nghĩa là sao? Nghĩa là mình sẽ có hai bên, một bên tên là một bên mình gọi là prover, một bên gọi là verifier. Thì bên prover là bên chứng minh, đúng không? Còn bên verifier là cái bên mà kiểm chứng. Thì giống như bên prover giống như là học sinh vậy á, còn bên kiểm chứng giống như là giáo viên vậy á. Thì giáo viên thì muốn kiểm chứng á, là đối với bài toán X thì sinh viên sẽ có một cái lời giải W, mà đối với cái giáo viên á, thì thật ra là hoàn toàn là không có quan trọng cái lời giải đó là gì, đúng không? Mà chỉ cần biết là lời giải đó là đúng là được, đúng không? Nghĩa là W này là một lời giải cho X, nó chỉ đơn giản như vậy thôi. Thì ở đây mình sẽ thấy được rằng á, là trong cái cách nhìn đối với ZKP như vậy á, thì ZKP rõ ràng nó là một cái ứng dụng cụ thể của cái MPC này, đúng không? Thì mình nhìn vô cái box này đi, lúc này thì cái hộp này á, mình cũng có hai bên, một bên là prover, một bên verifier. Thì bên prover này á, nó sẽ đưa bài toán và lời giải, còn bên verifier này chỉ nói là đây là bài toán mà tôi quan tâm thôi, x phẩy. Thì cái hộp này nó sẽ kiểm tra hai thứ. Thứ nhất là cái lời giải W là đúng, là lời giải đúng của x, đúng không? Và cái bài toán x này á, nó đúng là cái bài toán x phẩy mà bên kiểm chứng đang quan tâm, đúng chưa? Thì ở đây mình sẽ thấy là chỉ có một bên mà nó có thể có được bí mật thôi. Đó là cái bên prover này, chính là cái lời giải bí mật này. Còn cái bên verifier sẽ nó là một cái điều mà hoàn toàn là public, đúng không? Thì nhưng mà khi mà mình nhìn tổng quát thì rõ ràng là ZKP nó cũng chỉ là một cái ứng dụng cụ thể của MPC thôi. Nhưng mà bởi vì cái sự mà nó cụ thể như vậy á, cho nên ZKP nó có thể đạt được cái hiệu năng cao hơn là cái MPC tổng quát, không? Thì về cơ bản là khi mình có một bài toán tổng quát mà mình đưa về một cái trường hợp đặc biệt mình tính á, thì lúc nào mình cũng sẽ đưa ra một cái lời giải tốt hơn là lời giải tổng quát, đơn giản như vậy. Rồi còn khi mà mình ứng dụng cái MPC và cái ZKP này á, thì là mình sẽ có một số cái quan sát sau đây. Thứ nhất á, là khi mà mình có một ứng dụng tính toán, đúng không? Mình đưa ZK vào thì mình sẽ có một cái tính toán được kiểm chứng, đúng không? Tại vì thật ra ZKP nó sẽ chứng minh là mình có một cái quá trình giải đúng cho một cái bài toán, đúng không? Thì đó là một cái lời giải được kiểm chứng hoặc là một quá trình tính toán được kiểm chứng. Khi mà mình gọi là muốn thêm một cái tầng nữa là mình muốn cái lời giải đó không có được biết bởi cái bên kiểm chứng, thì lúc này mình có thể làm thêm một số cái tính toán gọi là che giấu như thế nào đó. Thì mình sẽ có được cái gọi là một cái ứng dụng nó có bảo vệ cái tính riêng tư của cái người chứng minh luôn. Một số cái ví dụ nha, giả sử như mình sẽ có ZKID như là cái hệ semaphore, thì nghĩa là sao? Nghĩa là mình có thể chứng minh là mình có một cái định danh thỏa mãn một số cái điều kiện nào đó. Ví dụ như mình trên 18 tuổi thì mình được quyền mua rượu, mua thuốc lá chẳng hạn đi, nhưng mà người ta hoàn toàn không biết số tuổi cụ thể của mình, đúng không? Hoặc là mình giả sử như mình chứng minh là mình có visa của một cái nước nào đó mà mình không có thể hiện hết tất cả thông tin. Ví dụ như là bên kia thì thật ra cũng không có cần phải biết được là mình bao nhiêu tuổi, quê quán ở đâu, mà người ta chỉ cần biết là đối với cái passport ID này mình có cái visa đó, vậy là được. Thì cái này là một cái bối cảnh mà rõ ràng là mình thấy là thật ra mình chỉ cần cái tính riêng tư cho một cái bên thôi, đó là bên đang chứng minh. Nhưng mà sẽ có một cái trường hợp mà mình muốn tính riêng tư cho cả hai bên, thì khi đó là mình sẽ cần phải sử dụng MPC. Thì ví dụ như là mình nhìn vào một cái ứng dụng khác của ZK trong là ZK Machine Learning. Thì Machine Learning là học máy, đúng không? Thì sau khi học xong á, thì mình sẽ muốn dùng nó để làm một cái gì đó. Thì sau khi mình học xong mình sẽ có một cái mô hình, và thông qua cái mô hình đó thì mình phải đánh giá được một cái mẫu mới mình đưa vào nó là nó thuộc một cái lớp nào chẳng hạn như vậy. Thì mình sẽ thấy là lúc này khi mà mình dùng ZK không, đúng không? Dùng ZKP không á, thì mình chỉ có thể bảo vệ được cái tính riêng tư cho một bên thôi. Thì lúc này mình phải chọn là mình muốn bảo vệ cái mô hình hay là mình muốn bảo vệ cái mẫu, đúng không? Này là mình phải chọn. Và người lớn không ai chọn hết, cho nên mình có thể sử dụng MPC. Thì MPC này mình có thể gọi là upgrade, mình sẽ nâng cấp cái ZKML thành ví dụ như là gọi là PPML đi, Privacy Preserving Machine Learning. Thì khi đó là cả cái mô hình và cái mẫu đều có thể bảo mật được. Ngoài ra thì cái này nó còn có một số ứng dụng trong cái tài chính nữa, nhưng mà không có thời gian cho nên mình sẽ bỏ cái phần này ha. Thì cái điểm nổi bật của cái việc mà khi mà mình upgrade từ ZKP app lên MPC app á, thì là mình sẽ gọi là có thể bảo mật được dữ liệu của nhiều hơn là một bên. Còn nếu như mình thực sự chỉ cần bảo vệ tính riêng tư của một bên á, thì dùng ZK là đủ rồi. Còn cái này là một cái khác chắc là mình không có thời gian nói nên mình sẽ bỏ qua. Rồi sau đó về cụ thể cái kỹ thuật mà làm MPC thế nào á, thì mình có một cái kỹ thuật tên là Gable Circuit, nghĩa là giống như là một cái mạch được mã hóa hay là được làm xáo trộn ha. Thì khi mà mình nhìn vào cái cách mà mình sử dụng cái MPC này á, thì mọi thứ nó cũng sẽ là quay xung quanh cái hộp này thôi. Thì giả sử như bây giờ mình có một cái hộp này đúng không? Là mình nói là cái dữ liệu đầu vào từ Alice và Bob đó là một cái mảng, một cái vector 3 phần tử mỗi bên, và mình muốn tính cái tích vô hướng của nó, đúng không? Thì chẳng hạn như là cái này là một cái mô tả của cái quá trình tính tích vô hướng đi, thì mình sẽ tính là XA0 nhân XB0 gán tạm vào một biến, rồi sau đó mình tính XA1 nhân XB1 gán tạm vào một cái biến mà phải cộng thêm cái biến trước đó nữa, rồi cuối cùng là mình có XA2 nhân XB2 cộng cho cái biến trước đó, thì cuối cùng mình sẽ ra được kết quả y này. Thì cái hộp này lúc này á, mình sẽ thấy là mình có một cái hoàn toàn là mình có thể tổng quát hóa nó lên, hoặc là làm cho nó gọi là không có bị chuyên biệt quá, là bằng cách là mình chỉ cần nhìn vào những cái này, đúng không? Thì rõ ràng là mình không cần phải hỗ trợ quá nhiều thứ, mà mình chỉ cần hỗ trợ cái phép tính nhân và phép tính cộng thôi. Nghĩa là nếu như mà mình có hộp mà mình có thể thực hiện được phép tính cộng và phép tính nhân bên trong nó, thì mình có thể mô tả bất kỳ một cái mạch nào mà mình cần. Đây là một cái hình minh họa cho cái quá trình tính toán mà hồi nãy mình tính ra, đúng không? Thì đây là một cái mạch là gồm có 3 cộng nhân nè. Sau khi mà nhân xong thì mình cộng từng cái lại nhau, cuối cùng là cái kết quả y này thôi. Đó, thì cái Gable Circuit này á, là một cái mạch mà xáo trộn, không? Nghĩa là mình hoàn toàn có thể thực hiện cái việc mà xáo trộn từng cổng. Đầu tiên là đây là cộng nhân, mình xáo trộn cộng nhân, xáo trộn cộng nhân, xáo trộn cộng nhân. Rồi sau khi xáo trộn xong á, là mình sẽ có cái kết quả tính đã được xáo trộn ở đây, và hai cái này có thể được đưa vào một cái cộng đã được xáo trộn. Và sau khi mà cộng này tính xong rồi đó, mình có thể đưa vào một cái cộng kế tiếp nữa, và mình thực hiện trên từng cái cộng như vậy là được. Còn một cái góc nhìn khác đối với cái mạch được xáo trộn này á, thì mình có thể hiểu là cái mạch xáo trộn này nó là một cái hệ MPC mà nó hỗ trợ được cũng hai bên thôi, nhưng mà nó hỗ trợ theo kiểu là có thể có tính riêng tư giữa hai bên ha. Thì một bên mình gọi là gambler, là bên làm xáo trộn, một bên gọi là evaluator, nghĩa là cái người mà thực hiện cái việc tính toán sau khi mà mạch được xáo trộn. Thì cái gambler là cái bên mà sẽ thực hiện cái việc xáo trộn cái mạch và gửi cái mạch này cho bên evaluator. Thì cái evaluator này á, thì lúc này á, là bởi vì là cái mạch này đã được xáo trộn rồi, bên evaluator sẽ phải cần lấy một số cái khóa. Thì những cái khóa này nó có thể gọi là giúp giải mã cái sự xáo trộn này, nhưng mà chỉ cho cái input là bên evaluator thôi, đúng không? Thì sau khi mà đã có đủ cái thông tin là XG và XE này rồi, thì bên evaluator có thể là giải mã được cái này và tính ra được y. Và y, nếu như mà bên gambler quan tâm luôn tới cái kết quả này á, thì bên evaluator có thể gửi kết quả này cho bên gambler. Thì cái đặc điểm của cái Gable Circuit này là sao? Nghĩa là thấy nó có một cái gọi là tính chất rất là hay, đó là low latency. Nghĩa là cái việc mà tính toán này á, nó không có qua quá nhiều cái tương tác giữa hai bên, mà nó chỉ đơn thuần là một bước gửi, một bước nhận, rồi cuối cùng tính toán ra kết quả. Nghĩa là sau 2-3 vòng tương tác là mình đã có thể có được cái kết quả tính toán rồi. Thì cái này nó cực kỳ thích hợp đối với trong cái trường hợp mà cái việc mà tương tác là một cái mà quá trình mà muốn tránh. Ví dụ như là bên Việt Nam muốn nói chuyện với bên Mỹ chẳng hạn đi, thì cái đường truyền internet sẽ không có tốt. Thì lúc này là nếu như mình nói chuyện, mình tương tác quá nhiều nó sẽ bị chậm. Thì thay vì như vậy mình dùng cái giao thức Gable Circuit này, thì mình hoàn toàn có thể sau 2 vòng nghĩa là mình làm xong cái phép tính. Có những cái giải thuật, có những cái giao thức khác nó sẽ tốn nhiều vòng hơn. Ok, thì mình cũng có chuẩn bị cái slide về chi tiết của cái này, nhưng mà chắc là mình sẽ đi qua thôi, tại vì cái này nó yêu cầu cũng nhiều cái kiến thức về mật mã, cho nên mình hãy đi thẳng đến cái cái cách sử dụng thôi. Ok, thì sau khi mà mình tức là đứng ở góc độ ví dụ như là nhà phát triển hay là lập trình viên, đúng không? Những cái bạn mà học về khoa học máy tính hay là những cái bạn khác mà muốn ứng dụng cái MPC này vào trong những cái công việc của mình, thì mình chỉ cần biết là cái khái niệm đó là cái gì, mình sử dụng nó như thế nào. Và thật ra cái việc sử dụng này nó quan trọng nhất là cái chỗ nào, nó là cái mô tả này, đúng không? Là làm sao mình có thể mô tả được cái mà mình muốn làm, được chưa? Thì thành ra cái việc mà sử dụng cái kỹ thuật double circuit hay là nói riêng hay là sử dụng kỹ thuật MPC nói chung á, nó đều quay vòng quanh cái vấn đề là làm sao để mình mô tả cái điều mình muốn tính toán. Nó khó nó như thế nào, nó dễ như thế nào. Thì đây mình có nhiều cái cách, không? Như là mình giả sử như mình dùng cái thư viện tên là MPC này đi, mình có thể sử dụng nó cái kiểu là gọi là mình thích khổ cực, đúng không? Thích trải qua một cái trong gai rèn luyện gì đó, cái kết quả mình đạt được mình cảm thấy xứng đáng, thì mình có thể lựa chọn cái phương pháp này. Thì khi mà mình mô tả cái mạch mà mình muốn làm á, mình có thể tập trung vào cái thư viện, cái phần gọi là cái module là MPC circuit hoặc là MPC circuit macro. Thì mình có thể mô tả một cái mạch nhị phân, hoặc là cái MPC circuit này là nó sẽ cho phép mình mô tả một cái mạch nhị phân nè. Còn cái macro này á, thì nó giống như là một cái kiểu gọi là hỗ trợ, một số những cái hàm hỗ trợ. Chẳng hạn như cái mạch nhị phân chỉ cho phép mình tính toán trên một bit đi, thì cái bộ mạch thì cái thư viện, cái module hỗ trợ này có thể giúp cho mình sẵn là mình tính toán trên cái hệ số 32 bit hoặc là hệ số 64 bit luôn, thì nó sẽ tiện hơn. Thì ví dụ như ở đây là tính toán trên từng bit ha. Còn cũng trong cái thư viện MPC này luôn á, thì ngoài cái hệ nhị phân ra, mình có thể tính toán trên hệ số nguyên bình thường. Thì cũng bằng cách dùng API, là ví dụ như ở đây mình nói là mình quan tâm là có 3 biến là A, B, C đầu vào, và cái mà mình muốn kiểm tra là mình có A, B, C đầu vào và out là ra. Thì cái mình muốn tính là A cộng B có lớn hơn C hay không, đúng không? Thì ở đây mình sẽ tính là đưa A đưa B vào nè, rồi sau đó mình tính D là bằng cái MUL này là multiplication, nghĩa là A nhân B nè. Rồi sau đó sau khi mà mình có được cái D này đó là cái kết quả của A nhân B này đó, mình sẽ so sánh với lại C. Thì mình muốn so sánh với lại C liệu D có lớn hơn C hay không đó, thì đơn giản là mình thực hiện một cái phép là D trừ C, rồi sau khi mình có kết quả E là bằng D trừ C này, mình sẽ kiểm tra coi là cái kết quả E này nó có lớn hơn không hay không thôi. Thì ở đây mình sử dụng là cộng nhân, cộng trừ là một cái biến thể của cộng thôi, và một cái hàm là kiểm tra là có lớn hơn không hay không. Thì cái này nó sẽ tiện lợi hơn nếu như mà mình đang mô tả mạch đại số. Thật ra thì giống như là mấy cái mà cách mà khổ cực á, thì mình nhiều khi mình nghe chơi cho vui thôi. Còn đương nhiên là mình sẽ muốn là làm sao mà mình sử dụng được cái mình có thể mô tả một cách dễ dàng hơn. Tại vì nhiều khi cái mô tả của mình á, ngay cả khi mà mình dùng cái cách dễ dàng đó, nó cũng có rất là nhiều cái logic phức tạp bên trong nó. Thì giống như hồi nãy cái bạn Leo bạn cũng giới thiệu về cái ngôn ngữ SOCOM này á, thì SOCOM là một cái ngôn ngữ mà chuyên dùng để mô tả một cái mạch. Thì nhưng mà cái mô tả này á, thì nó khá là trừu tượng, nó gần như là không có gắn liền quá nhiều với những cái hệ thư viện. Ví dụ như là ở đây mình thấy là ở đây nội cái chuyện mà mình tính coi A nhân B có lớn hơn C hay không, mà mình phải trải qua rất là nhiều cái bước như vậy. Thì ở SOCOM này mình chỉ có một dòng thôi. Còn đây là một cái ví dụ của SOCOM mà mình tính toán nhiều hơn, là tính cái tích vô hướng của hai cái vector A và B, mỗi vector có 3 phần tử. Còn cái cách sử dụng gọi là cái cách mà mình đi từ chương trình cho đến tính toán ra như thế nào á, Thì hiện tại là mình có thể làm theo cái kiểu là mình viết một cái chương trình bằng ngôn ngữ sơ com, rồi sau đó nó sẽ được dịch thành một cái mạch, và cái mạch này nó sẽ được đưa vào cái thư viện là MPC hay là MPC BMR16 này. Rồi cái này nó chỉ đơn giản là một cái giao thức để tính toán trên cái trên cái mạch này thôi. Thì mình sẽ tính được trên cái tính ra được kết quả. Một số ứng dụng ví dụ như là tính phân lớp học máy với sơ com, thì đơn giản là các bạn viết chương trình học máy, chương trình phân lớp học máy bằng sơ com, sau đó đưa qua cái chuỗi này, rồi một bên là mô hình, một bên là mẫu, thì các bạn sẽ có cái kết quả phân lớp. Nó còn cái việc mà làm sao để mà có cái như là phân lớp học máy bằng sơ com thì nó cũng có nhiều cái thư viện hỗ trợ sẵn rồi. Ok. Ngoài ra thì nếu như mình không thích thư viện MPC mình hoàn có thể thay cái thư viện MPC bằng một cái thư viện khác, ví dụ như là hiện tại có MP Speed hay là Motion, thì nó cũng hỗ trợ việc tính toán đa bên tương tự như MPC vậy. Ok, thì ok, cái cuối cùng mình muốn chia sẻ là cái việc mà những cái thư viện mà nó hiện thực cái cổng cộng với cổng nhân không thì nó sẽ không có tiện lợi lắm, cũng không có đạt được một cái hiệu năng cao. Thì thông thường là mình sẽ cần phải làm thêm một số cái cổng đặc biệt khác nữa, ví dụ như là cổng chia dư cho một cái số nguyên tố, hay là một cái cổng mà giúp mình có thể tính toán được trên số thực một cách dễ dàng hơn, hoặc là một số cái optimization, những cái tối ưu mình có thể đưa vào. Lấy ví dụ như là mình sẽ thấy là giả sử như khi mà mình phân lớp học máy, đúng không, phân lớp học máy ví dụ như là ở đây đi, thì các bạn sẽ thấy là giả sử như mình bởi vì mình dùng một cái giải thuật tên là Gabble Circuit, thì Gabble Circuit sẽ có bên là Gabler và bên Evaluator. Thì đối với Gabler thì cái này nó hoàn toàn là không phải là một cái bí mật gì, đúng không? Ví dụ như vậy, thì thay vì thực hiện một phép tính nhân trên hai cái số bí mật, thì mình hoàn toàn có thể thực hiện một cái phép tính nhân trên một số bí mật, và nhân với cái hằng số là một cái hằng số mà thuộc trong cái bộ input mà bên Gabler đã biết rồi. Thì một số cái mô tả cho cái để mà được tối ưu hơn, hoặc là cái phép mà chuyển đổi giữa số đại số và số nhị phân được dễ dàng hơn, thì những cái này nó sẽ làm tăng hiệu năng cái quá trình tính toán bằng MPC của mình. Ok, thì còn một số cái khác như là làm sao để mà mình có thể biết được là cái thông tin đầu vào của một bên là nó đúng hay là nó sai, kiểu như là kêu đưa vào số nguyên mà đưa số thực vô, hoặc là kêu đưa vào số dương mà lại đưa vào một số âm chẳng hạn. Thì mình hoàn toàn có thể làm một số cái kiểm tra trước khi mà chạy cái MPC này, để tránh là chạy tới cuối cùng mới phát hiện kết quả sai, thì nó sẽ rất là tốn cái công sức, hoặc là một số cái liên quan tới bảo mật khác thôi. Ok, thì các bạn có thể scan cái này, ở cái link này thì mình có để rất là nhiều cái thông tin mang tính kỹ thuật. Nếu như những cái bạn nào mà có muốn tìm hiểu sâu hơn thì có thể tìm hiểu tại đó.
Any question for Nam?
Em muốn hỏi là cái này thì ứng dụng trong web 3 sẽ như thế nào ạ?
Nó một câu hỏi rất là hay nha. Tức là bây giờ là mình sẽ thấy là tức là mình thật ra là bây giờ mình không có thấy quá nhiều cái tương tác thật ngoài đời trên web 3, đúng không? Nhưng mà giả sử như bây giờ công ty của bạn trả lương cho bạn bằng web 3 đi, bằng thông qua chẳng hạn cái kênh blockchain này chẳng hạn, đúng không? Thì bạn có muốn người ta thấy được cái số tiền mà bạn nhận hay không? Không muốn thấy, đúng không? Thì MPC lúc này sẽ dùng trong cái trường hợp đó. Hoặc là bây giờ giả sử như bạn có một số tiền ở trên blockchain đi, bạn muốn đi vay mượn, thì lúc này là bạn sẽ phải thực hiện một số cái ví dụ như là chứng minh tài chính hay sau đó. Nhưng mà bên chứng minh tài chính lại không muốn bạn biết cái mô hình mà người ta phân loại bạn như thế nào, đúng không? Thì tiền của bạn là gọi là, hoặc là cái lịch sử giao dịch của bạn, đúng không, là bí mật của bạn. Còn cái cách mà người ta phân lớp bạn cũng là bí mật của người ta. Thì rõ ràng trong cái trường hợp đó là mình bắt buộc mình phải dùng MPC thôi. Dạ vâng.
Bài của anh tôi thấy hay, cái đoạn đầu anh nói cái tương tác giữa allies và bot á, thì cái mô hình tương tác đó là dựa trên cái cơ sở lý thuyết nào? Bot allies.
Dạ anh có thể nói rõ hơn câu hỏi được không ạ? Thì cái mô hình này dạ cái này nó chỉ là một cái mô hình rất là bình thường thôi. Này là tương tác giữa, ví dụ như là đây là một cái chương trình máy tính, đây là một cái chương trình máy tính, và đây là một cái chương trình máy tính khác, chỉ là gửi nhận thông tin như vậy thôi, không có gì đặc biệt hết.
We're good?
Yeah, we are good.
Okay, thank you so much, Nam. That was, I hope, great. I hope you liked it. And I think that's a wrap for the day, actually. Do you want to say a final word, Skylar? We have a meetup tomorrow. We'll put up a QR code. We're organizing a meetup tomorrow at the Peridot Hotel. So I will put the QR code. You're all invited to join. We'll have a panel and drinks and food, and that will be amazing. You want to say something else, Skylar?
Whoops. Yeah, I speak loud, I guess. Yeah, just want to say thank you all for attending. Thank you all for listening. And thanks to all the speakers, those who are still here, to FOSSASIA team and Jack for inviting us. And yeah, tomorrow night we will have a meetup with free food, free drinks, and a panel about Ethereum in Old Town Hanoi. So sign up here. When you sign up, write in the form, write FOSSASIA Ethereum Builder Day. FOSSASIA Ethereum Builder Day. And we will approve it. That's your reward for staying until the end. And then if you are still interested in learning about Ethereum, later this year, we have an event called DevCon. DevCon is the Ethereum Developers Conference, where you can hear talks like you heard today, but in more depth and with thousands of other people who are interested in learning and building on Ethereum. This event is coming to Bangkok in November, to Thailand in November. And so if you're interested in that, I think there's more information on this QR code, probably, right? I think so. Yeah, so the left QR code you could scan to find more information about DevCon. There will be discounted tickets for all everyone from Vietnam. So there will be very, very, very much discounted tickets for all of you. And yeah, and thanks to Natan for emceeing the day. So thank you all. See you later.